Oh, there it goes. I forgot to plug in the microphone. Where the? There it is. I guess that would help, wouldn't it? I'm Groot. Bad Labrie. Happy, happy victims. Yummy, tasty victims. Happy, delicious victims. Mm. We're doing okay. It's finally starting. Oh, I got psoriasis. It's finally starting to warm up a little bit. We're going to be hitting 50s this week. My heater broke. So we were pretty chilly. We were thankful for a mild winter. Yeah, lucky. Very lucky. Cool. I'm Groot. Yeah, I think, well, we still have the potential for winter weather in March here. But so far we're looking like we're past most of it. It's starting to warm up, which is good. I'm hoping it'll get warm enough where I can start turning off that heater. I have one electric heater running. The problem is running a resistance electric heater costs $168 a month just for the one heater. So I'm hoping I can get to the point where I can start turning it off during the high peak times. You know, when electricity is 21 cents a kilowatt instead of 11 cents a kilowatt. So we're almost to that point where I can start doing that, where I can put it on a timer and just start turning it off during those peak times. Got a little spot out there. I can set timers to turn the power on and off on a time window. I can't turn the heater on, but I can turn it off. It's one of those electronic ones, so you have to press the little capacitive button to turn the heater on. Whew. Ouch. My electric bill last month was $274. That hurts. It's normally like $150 because the heat pump is significantly more efficient. Oh man, why I'm as soon as I start recording, I yawn. It's like my body goes, "Oh, you want to record a video? Now you're going to yawn a whole bunch." So yeah, winter's almost over. We're supposed to have it's actually supposed to be 59 degrees this Saturday and no rain. So I'm hoping to get the water heater working again. It's like the when it rains, it pours kind of thing. It's like the whole house fell apart this winter. So, no, it's not. It's yawning. I don't know what it is. I keep yawning. I got to yawn again. I can feel it. I'm trying to stop it. You can actually feel these muscles tense up when you try to stop it. But the heater failed. The heat pump failed. The hot water tank failed. The kitchen hot water tank failed. The refrigerator failed. The toilets failed. The washing machine failed. It's like, what the fuck? All within a month. So I got the one toilet fixed. I still have to fix the other toilet. The electric water heater under the kitchen sink, it just died outright. It might be under warranty since it seems to be an electrical failure. The lights on the front of it stopped working, and then I started hearing like buzzing sounds coming from inside of it, and then it died completely after drawing like 3 times more power than it normally draws. And then it just died. It doesn't draw any power now. So a replacement for that will be here tomorrow. So that'll be fun installing that. And then the element, most likely the failure of the main water heater is the element. The hard water around here is brutal on the elements. I got 3 years out of that element. That's pretty impressive. But come summertime, I got to get my rolling staircase out back here because the hot water tank, you can't reach the top of it. There's no easy access to the top of the water heater because the water heater is inside the house, but it's not accessible inside the house. There's an additional door on the back of the house, and you open that. It's just plywood. I actually got a door to put on there, so it'll look more nice. But it's a door or a hatch on the back of the house, and you open up that hatch, and that's where the water tank is. And the problem is, what do you see, baby? You see something? Good boy. Yeah. You see something outside. So that water tank is 3 feet off the ground. So the top of the water tank is about 8 or 9 feet off the ground. And I don't have a ladder that'll hold me, but I have a rolling staircase. So once it's warm out, I'm going to bring that up back because I got to check the sacrificial anode to make sure that's still good, because that will help extend the life of the element. So I have an element already. I just got to wait for a warm day to go drain the tank, swap the element, and then I can get a shower again. And then I got to fix her toilet. And then I got to figure out how to okay. So all washing machines have a drain on the bottom. It's a little, plastic cup-like filter thing. You twist it, pull it out, and it catches debris. Keeps you from clogging up the pump. And on the older machines, the morons who design these machines, and I'm going to call them morons because it takes a moron to do something this dumb. The filter's behind a panel that has to be removed with screws. It's like you don't think maybe the end user is going to want to be able to access that filter to clean it out. So this one looks like one of the older ones where I have to partially dismantle the machine to get to that filter because it goes through the wash cycle and then gives me an error 0. And when I look up that error, it says there's water in the bottom of the machine, so it's not draining correctly. And usually that's related to that filter screen being clogged with something. And I'm hoping that bottom panel removes. I haven't checked it yet. But on my old machine back in Pennsylvania, I had to actually dismantle the entire front fascia of the machine to get to it. So, of course, after that, I took a hole saw and I put a fucking hole right through that front panel so that in the future I could stick my hand in there and get to that filter. It's like, was that so hard to put a little hatch right there for people to access that filter? I mean, that's a consumer necessary accessible component. Oh man. But So hopefully the washing machine's not dead. Hopefully it's just something clogged in that filter and that's preventing it from completely draining. I mean, the machine's not full of water, so it is draining. It's just, I guess there's enough in the bottom there that's tripping the sensor. And and then for the mini split, I haven't heard back from him yet. So I don't know if he's still in business or not. So I might be burned on that. Yeah, that's gonna suck. That's gonna suck hardcore. I've tried my third universal remote for the Whirlpool. I can't find a remote that'll work for it. It's kind of a vicious catch-22. Every universal remote, if one of the built-in codes doesn't work to program for the machine, it has a randomizer function. If you've ever programmed the universal remote, you know what I'm talking about. You'll do something like, power up, power up, power up, power up, power up, and when your TV turns on or off, you got it. Every time you hit up, it's going to the next code. And so you just sit there hitting those two buttons, ding, 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 ding. Oh, there it goes. It turned off. That's the code. And then you can tell it to read you back the code. And now you can write down that code, and that's the code for that TV. Well, for whatever reason, these remotes use changing the temperature as the litmus for whether the remote is working. So instead of, whatever key to change to the next code and then the power button, you have to hit whatever key to change the code and the temperature up button. And when you see the temperature change, you found the code. Well, here's the fucking problem with that. It has to already be on to do that. And I can't turn it on. And there's no buttons to turn it on. You have to use the remote to turn it on. It's like, who designs a machine like that? Oh my god! It's like who does that? Who designs a machine like that? You can't program a remote unless you can turn it on, and you can't turn it on without the remote because there's no buttons on the machine anywhere. I know it works because when I plug it in, it beeps to indicate that it's got power. But if I can't turn it on, I can't program a remote. And I can't find a replacement original remote. Oh my god. Sometimes you just want to find, it happens all over the place in all industries. It's like my car. The built-in, it's got a voice button on the steering wheel so that you can do voice control of the car. Now, why the fuck would you want to do voice control of the car? So you can keep your hands and your on the wheel and your eyes on the road. Okay, so you don't have to look at the goddamn screen and crash your car. Okay, makes sense, right? Yeah. Well, this user interface with the voice control is such absolute bullshit garbage, even in the second generation car. It's so garbage that I desperately want to fly to Japan, find the software engineer who designed the UI for this car, bitch slap him with a wet trout. Well, it's Japan, so let's use a koi fish. All right, bitch slap him with a koi fish and say, "Did you ever use the fucking interface you designed?" Because it's a voice interface that requires you to look at the screen. And look carefully at the screen, not just glance. You actually gotta go, crash! It's such a bad UI. Oh my god, it's so bad. Like instead of being able to say, navigate to 500 Winchester Drive, 87015. No, it's navigate, then wait for the next command. Where do you want to go? I want to go to here. And you got to give the address one piece at a time. It's such a garbage UI. It's like, It's like Google and Siri have been around for almost 20 years now. At least 15 years. This is not rocket science. So you got a manufacturer who designs a device that can only work with a remote control, and if you ever need to replace the remote control, fuck you. You can't turn the machine on without the remote, and you can't program the remote without the machine being turned on. And then you got manufacturers who make um, washing machines with user required accessible drain catch filters that can't be accessed without dismantling the machine. And you got car UIs that have voice interfaces that are so bad you have to look at the screen one step at a time to do it. Why did it do that? That was weird. I mean, it's like it's clear. It's very clear that these people are either demented and weird, have an ulterior motive, or they never actually used the thing they created. They never actually had to use what they made. It's like, come on, this is not rocket science here. This. I mean, we're not even talking about niche case rare things. Needing to clean out the filter catch basin is a normal thing. It's a normal maintenance thing. Actually being able to use the voice interface without taking your eyes off the road, that's a duh thing. That's the intended purpose of the voice interface. And losing the remote for any device is one of the most common occurrences in the history of remote controls. And they all failed at designing. It's not like they it's not like it's some crazy niche, weird, strange occurrence thing that how could any of us thought a person would have needed this? It's not like one of those kind of things where okay, I can understand them not preparing for that because who would have ever thought that would happen, right? But no, it's like the most common thing you could expect to happen, the most obvious thing, and they didn't design for it. It's like the washing machine. I wonder if it was intentional. I wonder if they intentionally hid away that filter receptacle. It's literally a little looks 3D printed, but it's not, of course. It's a little cylinder that's open on one end and it's got holes on the other end, and the water just passes through it and it catches any debris that might get stuck in there, hair, sock, whatever. And I wonder if they intentionally designed it not to be accessible to keep their service technicians in work. As the machines got better and better and need less service, if they did that to keep their service technicians, so every year or two you'd have to call a service technician just so he can go and put it back in. But he has to dismantle the front of the machine to get to that. It's like having something like this. So you have batteries that have to be replaced. And let's say they include the batteries, but there's no battery door. Where is the battery door? And there's no battery door. And instead, you have to, break these seals, undo 18 screws, open up the back panel, then open up 7 more screws to access the box that contains the battery. And then finally you change the batteries, and you got to repeat all that to put it back together. It's like they did that. Well, I think that's part of the problem. This is from another country. This is a Whirlpool 12,000 BTU mini split, but it's made in Mexico. So, for example, one of the weird things that is with it is it only displays temperature in Celsius, which, let me tell you, is a royal pain in the ass. Celsius sucks. Unless you're an engineer dicking around with freezing and boiling water, Celsius sucks, especially when they only use whole numbers and they don't allow decimal places. Because the difference between 1 degree Celsius is like 2.7 degrees Fahrenheit. That's a big swing. 2 degrees, almost 3 degrees is the difference between comfortable or not comfortable. And that happens with that unit where at 20 degrees, I'm too cold. At 21 degrees, I'm too hot. It's weird. But, Fahrenheit is just better for temperature. If for no other reason than it's more granular. If you're gonna use Celsius, make sure you have 1 decimal place. So I can set it for 21.5 degrees Celsius. I don't have the model number. I'll have to get up on a ladder and see if there's a model number somewhere in there. But you know something? I downloaded the remote at some point in time. Not the remote, the manual. Because and that's what pisses me off is that I thought about the remote problem with the machine when I realized it didn't have a power button. So I bought oh, I do not have the remote there. Because I bought 2 replacement remotes, lost those 2. No, I got 3 remotes in this thing, and I have no idea where they're at. I think they're on one of these shelves somewhere, or in the container. Like I may have moved stuff off of here into the container and not realized I moved something I needed. I'll find it, and I appreciate any help trying to find a remote for the damn thing. The problem is I'm kind of tired of buying remotes. Well, we got to remember, even though I set the machine to 20C, it never actually reaches 20C in here. There's a delta there. So, for example, it might be 20C, 9 feet up there at the peak of the ceiling, and then 2 feet below that it's 19, and 4 feet below that it's 18, and down here it's 16. So there's a definite delta. I actually discovered this year it works a lot better if I turn on the ceiling fans, because the ceiling fans circulate the air in the room, which makes the temperature more consistent. Because I would set it for 20C and it would turn off and it would still be cold. Like, what the hell? And well, I'm sorry, I never actually got the house to the temperature it was programmed for. I'm speaking summertime when I'm using the air conditioner, in which case it could easily cool down this entire house. So 20, I think it was a 21C would be too warm and 20C would be too cold. And I always wished I could set it for like 20.5C, because it's very capable of cooling the house. But for heat, it never reaches the temperature. And I finally figured out that the units were turning off before the house got to the warm temperature. And that's because it was warm enough up there where the unit is and where the temperature sensor is. So when up there got warm enough, it would turn off. And of course, down here it was too cold. I finally figured that out, and then I started turning on the fans. And then, of course, the whole thing died. Brand new $5,000 system, and but so yeah, the setting it for 20C doesn't mean it's reaching 20C. But the point is, the point I was trying to make is that centigrade without decimal point is, although maybe this is a me problem, maybe this is a desert problem. I noticed that here where the humidity is ultra low, temperatures are more sensitive. So, like in Pennsylvania, it didn't really matter what I set the temperature to as long as it was close to what I wanted. It was comfortable. Here, you kind of really need to fine tune it. You don't need much, because in the desert, you have low humidity, so it's very. I think the problem is it's easy to overcool. It's easy to cool too much because of the low humidity. So you gotta, in Pennsylvania, you just blast the air conditioner all the time because it was always hot. Here, it's not always hot. So sometimes you need just a tiny bit of air. You need just that, you're just slightly warm and you want that little tiny bit. And it's hard to get that little tiny bit. So it might actually be geographical to here. And of course, we're at 6,800 feet, so the air's thinner, colder. So this decimal issue might be a complete non-issue at normal elevations and normal climates. So it might be a unique to high altitude desert kind of places. I don't know, but I have to live with it. So not having that granularity sucks. But it's just funny that they design things like this. It's like, I don't know, it's weird. And then like the heater, it runs for 24 hours then turns off. Why? Why run for 24 hours and turn off? Well, fire risk. Well, if it's a fire risk, it'll be a fire risk an hour after you turn it on, or 6 hours after you turn it on, or 18 hours after you turn it on. What's special about 24? Does it suddenly blow up and burst into flames after 24 hours? But no, so every day we have to hit the button, tap tap, to reset that 24-hour timer, and it doesn't count down, doesn't tell you, doesn't nothing. It just turns off. We're like, what? Why did that turn off? So every day we have to get in a habit midday of tap tap on the power button to make sure it doesn't turn off overnight, since that's when it's coldest. But just all those user interface and design choices that are made, it makes you go, why did you do that? It's like there's no how much would it have cost you to put two buttons on the machine? Two buttons. Because that's all you need. You only need two buttons. You need a power button, and you need a button to switch between heat and cool. That's all you need. You can make the cool a default temperature. You can make the heat a default temperature. But just give me two buttons so that in a worst case scenario where I've lost the remotes, I can at least turn on the air and turn on the heat. How much would that have cost? 6.5 cents? What would it have cost? 6.5 cents? It's summertime. Press power and then press the switch function button until it's on cool. In the wintertime, press the switch function button so it's on heat. Maybe I can't change the blower speed. Maybe I can't change the temperature. Maybe I can't change the oscillation and the timer functions, but at least I could still use it. At least it would still function. So now I gotta find the remote. What a pain. So I've been dicking around with the rocket parts, and we actually, I got a, rockets are, especially when you're dealing with larger rockets. I'm working on the Dragon. That's my current model I'm working on. I finally got the 3D prints to index so that the launch lugs that I print on this piece line up with the launch lugs that I print on this piece. That was a pain in the butt. Actually, it wasn't that bad. I made 2 test prints, saw how much they were off, and I just had to adjust the female mold without adjusting the male mold until I adjusted them enough. So it was about 60 degrees off, and then it was 5 degrees off, and then it was 1 degree off, and then I got it close enough. I'd rather have it slightly over tightened, because then you can just stick a piece of tape on the inside here to make it a little tighter, to make it align. But because the problem is these 2 launch lugs aren't enough, especially because there's 2 more sections that go on here. And so what happens is the wind pushes on this tall portion of the rocket and tries to pull it away from the launch rod, and it really stresses these 2 launch lugs. It's not going to break them, but it could cause the rocket to jam on the pad and rod whip pretty badly. So you want at least 2 more. Actually, you don't even need 2. Only that one's enough. But it's 3D printed, so I put 2 more. And now you have 500 millimeters between, or at least 400 millimeters between the top and bottom lug, and that's enough to keep it stable on the rod, and to not whip or jam or get stuck. And because the problem is, you have to line them up close enough that when the rod goes through, that, like, for example, the rod is like 6.5 millimeters, so I put a 7 millimeter hole, so I have a 0.5 millimeter of wiggle room. So if these are off by 0.5 millimeter, the rod will still slide through smoothly, but more than 0.5 millimeter, they won't. And the error between this part and this part is cumulative. So you'll be okay here, but then when you add an additional part here, it doesn't line up anymore. So for example, yeah, I can do that. This, I believe, is the same part, so this should line up. And it does line up, but if you look carefully, you'll see that the red ones are just a little bit more that way than the white ones. So the white one lines up, but by the time you get through the error accumulation from this part to this part to this part to this part, this one ends up a little off. And if you turn it back to where it's aligned, now it's too loose, because you need to tighten it to cinch it to stay in place. So that cinching it puts it about 2 millimeters off, so it's about a 1/4 millimeter per part. I'm losing a 1/4 millimeter just from the 3D printing process. And there's probably no way to fix that without making, probably the only way I can fix that would be to design new threads with a physical stop. So right now, the way the threads work in the 3D print, this is what I call a test chunk. So it's a small enough piece that's easy to print, but it's long enough to have all of the architecture. So you have the female cut, the male cut, the launch lug, and a section of tube. And the idea is you print the test piece, and first of all, you test to make sure your parts fit. So you can make sure you have a nice, there should not be a whole lot of play. As you can see, there's very, very little wiggle, very little play, especially once you get about 3/4 of the way in. There's almost no play. That's what you want, but you also want to make sure that you can turn this without having to fight with it, like I have to fight with that one. Now, of course, it's a dual start thread, so you can be in the wrong position where they're opposed. So you just gotta go to the next start, and then you'll be lined up. The way that the thread works is that the threaded part here, it bevels down, and of course on here it bevels down as well. So as those two bevels come together, it cinches the part into place. I can't just go a straight hard stop, because a hard stop, if the part is a little too loose, then it's always going to be a little too loose. There's no way to tighten it. By having the cinching bevels, it's a lot easier to 3D print, and it tightens itself. When you tighten it without having to crank it, it snugs up like a friction fit. Yet you can still back it off. Well, the problem is that friction fit has wiggle room. You can tighten a little too much or tighten a little too little, and you have to account for that wiggle room to a certain point. The only way I could fix this, and I don't have the skill yet to do it reliably and repeatably, is I would have to have both a cinch and a stop. So I would have to have a cinch that tightens up, but a stop that stops you from going past a certain point. So that you'll have a flat face on here, and you'll have a flat face in here, and those two flat faces will key. So this thread has a flat face, and this thread has a flat face, and those two pieces hit like this. And so you're keyed. Now you hit that, and you cannot go any further. The problem is I need it to cinch up just before it hits that, so that by the time you hit that, it's tight. And doing that is really, really hard. Could I do it? Yes. Could I repeat it? Yes. Could 100 people with their own printers at home repeat it? Probably not. Your extrusion multiplier being 1% plus or minus is going to make the difference between whether you cinch up and never reach the stop, or you reach the stop but you're still not tight. And it will make that big of a difference. The tolerance has to be that close, less than 0.1 millimeters. And that's really hard to do. The only other way I might be able to do it, and the problem is this would make it a wear component, is I would have to have a detent. So think of this, a shape like this, and a shape like this, and then it would get forced over this detent here, and then snick into a lock. The problem is this lock has to be tight enough that it doesn't wiggle, but flexible enough to get over this detent. So as you tighten the thread, you'd hit the detent, flex over it, and then drop into the lock. Again, doing that with 3D printing, really hard to do, especially when you're, could I do it? Yes. Could I repeat this on 100 random printers out in the wild? No. Not easily. So the easiest solution is to have a simple cinch. Tighten until it stops, until it's tight, until it's not loose. And then just get it close enough. So I can get it close enough that um, one part lines up reliably, that these two threads reliably line up. But once you go to third part, probably close enough, and you can make a third part work by adjusting the cinch. So what I would do at that point is the top of the thread, which is right there, okay, I'd put a little piece of masking tape right there to force it to cinch up a little bit sooner. So if your third piece goes too far out of alignment, a little piece of masking tape, and now it'll go a little less. That's something your user can do. Going beyond 3 pieces, that gets to be a real pain in the ass. As you can see, we're fully at 4 pieces. These are all using the same printer and the same profile and the same settings. My ideal environment. You can see that this I can't see part of the screen here. There we go. So the result is that these two line up. These two mostly line up, but by the time you get to this fourth one, you're 2 millimeters off. And that's enough that the launch rod's not going to go through. And if I loosen this enough to allow the launch rod to go through, now it's too loose because it's not cinched anymore. And you don't want that. You definitely don't want that. So you got to work on that. But so far, that's working great. So far, it's working good. Hey, Ben. One of the problems is there's a couple of components in the rocket that required bottom layer. So this is a centering ring for the original design. This one here, I think. Yes. So this is a centering ring for the original design. Now, this one's a little bit too small. I have to make it a little bit bigger, but it doesn't matter. This is dead. Hey, Steven. But there's an ejection charge in this rocket. The motor has an ejection charge. That ejection charge is basically a little black powder charge. It lights off, creates a whole bunch of gas. That gas pressurizes the rocket and blows the nose cone off. Well, what if the nose cone's a little tight? Well, you got to make sure that it builds up pressure and actually pops the nose cone. So you can't have this be hollow like this. If it's hollow like this all the way through, the gas is going to take the path of least resistance. And that path of least resistance might be out the back of the rocket. So even though I can't perfectly seal it because this is modular, I can seal it enough to make forward the easier path. And that's why this has bottom layers. Well, I finally figured out how to do this without bottom layers. So the motor mount is the same deal. So here's the thrust ring for the larger model. I'll get to what that is in a moment, but same deal. It's hollow here, which is a problem because the gases can pass through. So they can pass through this, and then pass through the motor mount. So I have to add bottom layers to make sure that there's actually some resistance to the gas going backwards out through the back of the model. And well, if you've done enough 3D printing, you know that layers in general are a problem because that's where you're not, as long as your first layer goes down, you're not going to have a problem with vase mode, because vase mode is constantly lifting the nozzle. And since you're constantly lifting the nozzle, you're constantly moving the part away from a collision. So even if you over extrude a little bit, it doesn't matter. The nozzle's constantly going up. Also, it's following a yes and no. I'll get to that in a moment. You can also you also don't have to worry about collision because you're following a spiralized path. So you're never ever leaving the outline of the model, and you're never ever crossing over the same part of the model twice. So for example, when I draw something like this, okay, so in one pass it's going, it's drawing this pattern, but then it has to come from this side and draw the pattern going this way. So now when it draws this way, it's crossing over the filament path that it already laid down to go this way. And each time you have a crossover, you have a chance of a collision. And every time you have a chance of a collision, you have a chance of failure. Phase mode also eliminates retractions, because every time you have a retraction, there's a chance of a clog, there's a chance of a booger, there's any number of failure modes. All don't exist when you do phase mode, because you're first of all, you're extruding and never stopping. You're never slowing down. You're never retracting. You're never travel moving from one point to another. You're never crossing over your filament path. And you're never leaving the filament path that you're extruding. It's one continuous candy cane spiral all the way to the top. Very complex candy cane spiral, but it's still a spiral, which means as long as that first layer sticks, it's virtually error-proof. Now, the only catch is very small contact point with the bed, so you need to use a brim. Now, if you're using a build tack, fake tack kind of surface, you don't need a brim. Yes, I know. The problem is, I think that's the problem I have with the Anycubic Mega Zero, and there's no option to turn off recovery mode. So the only way I could do phase mode is I have to slow down to like 20 millimeters per second. I have to slow down enough, and even then you still get little tiny blobs every now and then on that one printer, which is a pity because that printer would be great for this. So I got to find out. I got to see if there's a firmware update for it that gets rid of that problem. But so few people do this kind of phase mode stuff that sometimes it's not a priority. True, if the firmware is available, yes. Although Anycubic's pretty good with that, so it should be available. So, but the point is, phase mode eliminates so many user error problems, mechanical error problems, filament error problems, and slicer error problems. As long as it slices correctly, and as long as that first layer sticks, you've got like a 99% chance of that print finishing successfully, as long as it stays attached to the bed. And of course, as long as the end user, the designer, designed it right. Yes, but in order to update Marlin yourself, you need the original source code for the printer. So, but yes, as long as the source code's available, I can then update Marlin myself. Which I really should learn how to do. I don't dick around with firmware too much because, well, I'm a 3D printer user and model designer. You don't need the original source to write firmware for the printer? I thought you needed the original source to do that. Or are all these machines so similar that it's pretty simple to configure firmware for it? But that is something I should learn to do. Just because, I'm into this 3D printing thing so much, that's kind of an aspect I should learn how to do. But like, for example, I've never updated the firmware on a single printer I have. As long as the printer functions the way I need it to function, then I don't have a need to update the firmware. So, but because a lot of you guys do update firmware, I should learn how to do that. So that's something I'll work on. I'll probably start off with something like an Ender 3, which is easy to dick around with. And, learn how to mess with the config file and stuff like that. I know it's not hard. It's mostly commenting out and commenting in the stuff you need, knowing where it is. I know it's pretty straightforward. I know it's not that difficult. Unless you're trying to do crazy things, but for just simple fixes. I appreciate that. I might take you up on that. So I've been trying to, layers is a problem. Because first of all, phase mode is a single perimeter. And single perimeter plus infill can sometimes fail. And on top of that, a improperly leveled bed that still sticks will print phase mode just fine. But an improperly leveled bed that doesn't, that does layers can fail. And you can get things like this. Now this failure happened to not be catastrophic and the part is still usable. but that's mostly because it's a gigantic part with a 0.6 millimeter nozzle. So I was laying down some pretty fat extrusions. So I got lucky. If I did that with a 0.4, that would have failed. So by making the model strictly vase mode, I can eliminate 99% of the problems that result in the failure of a print. And so these three components, the centering ring, the thrust ring, and the motor mount, which you just saw here, these three components require bottom layers because you don't want gas transfer between the segments of the rocket. So I figured out how to get rid of that and also strengthen the part, increase the speed of the print, and make it lighter. So I did this. It's okay if one end is open as long as the other end is closed. You can see I did the same thing here. I only put layers on one side because I don't need it on the other side because this side has it. So now every piece has a cone. So this goes all the way up until it gets to the size of that hole so that I can make this edge 0.8 millimeters wide, or exactly 2 extrusions next to each other. So now the gas, yeah, I bet. Gas transfer or gas expulsion. There's this video of this little dog that goes up to a cat, and the cat's ready to swat him, but the dog keeps his distance. And you can clearly see the dog's doing it on purpose. It's hilarious. The dog turns sideways, his side of his body's facing the cat, and he's looking at the cat, and then you see him turn his butt and go, and he farts on the cat. And the dog waddles, and the cat goes, bleh, and then chases after the dog. It's like, he did that on purpose. That's awesome. It was like the dog said, fuck you. It was like, fuck you, Ezekiel. No, fuck you, Tony. Oh my God, the interactions sometimes between animals, it shows that they have far more intelligence than we give them credit for. It's absolutely hilarious. So now all three of these parts will have a cone that comes to basically a point. It comes to 2 layers, and that will allow me to eliminate top and bottom layers. So now this part, once again, prints vase mode with 0 top and 0 bottom layers, and yet it's still sealed. And so that's going to work out really nice. The only holes is the holes for the shock cord to go through, but that's a restrictive opening. That's not going to allow easy transfer of gas. So that works out well. I fixed that, so now all these parts will have that repair in place. If you are a Patreon member, you already have access to the hammer. That's not the dragon. The dragon's a different file. Patreon members are going to get all of these for free, but I'm going to be selling a lot of these. The hammer is going to be free. That's a downscale of the big one there, that fin design right there. So you saw the clear one that I posted, transparent one. It's really slick. That's actually what this red part is. I finally finished the files and I sent them off to my beta tester, and so I started printing all the files. I wanted to print the fin can, but the file name is 1 character too long for the CR6SE. If you know about Creality's new printers, they can't handle long file names. If the file name is past a certain number of characters, it just doesn't show it. It knows it's there because it has the number of pages, but it doesn't display it. So I guess 3INV4-245 space hammer fins is 1 character too long, because hammer lug, this one, showed up, but hammer fins, which is 1 character longer, is not on the card. It's there, but it doesn't show up, so I gotta redo it and make it show up. Take 1 letter off. So now these are all 200 millimeter parts, so that pretty much anybody can print them. If you have an Ender 3, you can print it. If you have a Sapphire, you can print it. If you have a Delta, you can print it. Hey, Mike, we're talking about the Dragon today and the process of iterating this design to make it work and all the different little neat things I'm doing to make models. I finally got this design, so it didn't get to the point where I printed a lug yet, but this was the 75 millimeter one. but this is now defunct. This will not work. Well, technically it works. I've been having. I slice my models with Simplify 3D, and they slice perfectly 99% of the time, and the prints are ridiculously strong. I mean, the whole purpose of this test print, that the user is going to have to print 2 of these, make sure the lugs line up, make sure they thread together nicely, and then once they confirm all that, and once they print it so that it works correctly, like if it's too loose, they got to increase the extrusion multiplier. If it's too tight, they got to lower the extrusion multiplier. That's basically all they have to change. And this makes it easy. It's like a 2-hour print, an hour-and-a-half print. I don't suggest going fast, even though you could print this part in 30 minutes, even on a regular Ender 3. The problem is you want the nozzle to linger a little bit, because this depends on filament touch fusion. So technically, okay, this is an older model, so this one they actually do this, but basically these ribs only touch one surface. Well, we already confirmed that works. These ribs only touch one of these. So on this particular model, they pierce the outside, they don't pierce the inside. I redesigned it so that, actually you can use this, but this one's easier for you guys to see. So, but on the new one, I do it from the inside. I went through the work to do it from the inside because it works better. Ringing can have a big impact when it's on the outside. Ringing has less of an impact when it's on the inside because it's moving slower. So what happens is it draws the inside, and then it draws this rib, but then it doesn't go through the outside. It touches the outside wall, turns around, and comes back. You guys know that's how I do my vase mode thing. So it goes out, comes back, goes out, comes back. Now the problem is this rib does actually need to touch the outside, and it needs to melt it because it needs to actually fuse. Okay, so there has to actually be fusion between the rib, because this is what's called an engineered structure. I could make this strong just by putting 20% infill in here, and this will be crazy strong. It'll take 3 times longer to print and use 2.5 times more filament. And it'll be 3 times heavier, or 2 times heavier. It'll be a lot heavier. The entire rocket he built, with the motor, the parachute, the shock cord, everything, the tube in the middle, ready to fly on the pad, was 23 ounces for a 3-inch diameter, meter-long rocket. Considering that it's made out of plastic, that's pretty damn light. That's not bad at all. Normally you'd use a tube like this, and it'd be close to as heavy. So considering it's all plastic, not bad, and it flew fantastic. I'm going to show you guys a video. He got video for me. So if you under extrude, then this outer skin won't be attached to this inner skin, and you'll have separation. That's why you make a test print, because you can see in here there's ribs inside there. Yeah, there you go. See those ribs inside there? So this is actually a hollow wall. You can see it right here. See how there's an inside wall and there's an outside wall? There you go. Actually, it's easier if I show you on the big one. So it's like corrugated, it's like cardboard. It's literally plastic cardboard. I'm making plastic cardboard. But we actually have a name for that. There's a company that makes corrugated plastic. It's called Coroplast. They made airplanes out of it. No, RC airplanes. Incredibly durable. So that is the inside wall and the outside wall. And as you can see, there is fusion between the inside wall and the outside wall. So in the 3D modeling software, that rib only touches the outside. It doesn't actually go through it. But on here, you can see I can't separate that outer wall from that rib. It's attached, and that's because I got close enough for fusion. You have the existing. Let me put it down. So here's your outer wall, and here comes the nozzle drawing one of those ribs, and it goes boop and turns around and comes back. But that boop is enough that molten plastic adheres, fuses to the outer wall, and you end up with a solid rib instead of a slightly separated rib like this. So when you print this test piece, the first thing you have to do is squeeze it. If you hear crunchy, 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 you're going to hear a little crunch, you know, because the edges never quite fuse correctly, and that's fine. But if you're hearing crunch, 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 and you're feeling movement, and this doesn't feel like a really, you should be able to squeeze this pretty hard, and it should not give, and it should barely flex, because it's an engineered structure. It's an integrated structure. You have an outside skin, an inside skin, and a set of ribs all integrated together to make it strong. It's like if you did this to make a table. It's not very strong, but now you can. Now I could make it all one piece and make it stupidly strong by having, you know, the sides be like this and this be like this and the front be like this. But I want the front open because I want to stick a TV in there or a microwave in there. So the way we do that is by having reinforcements. I can either have this piece fit in this piece like that, which will make it a more structural, give it more structural integrity, or I can add a little brace, a triangle brace to make it a triangle like that. You see this all the time in design, and that's an engineered structure. You're adding structural integrity by design, and that's what this does. I am engineering integrity into the design without adding a lot of mass. But in order for that to work, it'd be like you putting a triangle brace and not screwing it in. Well, it's not going to work. It's not going to do anything. It's not screwed in. It's just going to fall off. So same thing here. The ribs must fuse to the rest of the model. So they have to print until that happens. Well, there's two kinds of ribs on every one of these pieces. You understand vase mode, I have this surface and I have this surface. That's not vase mode compliant. So this is not vase mode compliant, but this is vase mode compliant. Why is this and not this? Because this requires me to draw this, and it requires me to draw this. But this is all one surface. See, I can keep going around in a loop without ever having to stop. Well, all I'm doing is bringing this so close together that it can still pass through, but it fuses. So I have a solid tube that's still vase mode compatible. So technically there's a gap here, but because we're over extruding on purpose a little bit, and because the tool path is still able to calculate a valid path, it's like as I pass by, I go and melt the plastic next to me, and we bond together. And that's exactly what's happening. So you have to make sure you are extruding enough. For example, I don't know why, when I print PETG, I have to extrude 5% more. For whatever reason, PETG does not extrude as even though the measures the same diameter, it doesn't extrude as, it's not the same. I don't know. I have to increase. I print at like 0.92 or 0.93 for PLA, and I print at 0.98 for PETG. If I print less, I don't get proper fusion. So you just have to, that's what a test print is for. Slice it, test it. First, does it squish? I don't hear no crinkle crinkle. I don't hear no crunchy crunchy. Nothing's moving around. The skin isn't separating. And then you find the seam. Does the seam pull apart? No, the seam doesn't pull apart. Okay, now see if they fit. So now this one's a bit damaged. I tested it to destruction. There we go. Make sure it threads. Make sure there's no play. Make sure there's no wiggle room. Make sure these line up. Yeah, I got different amounts of shrink, I guess. But make sure the lugs line up. Make sure this fits together nicely. Make sure you got a nice joint on the inside here. It's nice and smooth inside there. It's almost a seamless tube. I got lucky. It came out really nice. And make sure all they line. Once you confirm that's good and you have no crunchy, 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 you can squeeze it and it's not going crunch, crunch, crunch because it's not connected. I should do one on purpose that's not right. Like purposely under extrude just so people can see the difference. But once you confirm that, then you destroy one. So you take one, you find the seam, which is right here, and you just start killing it. And you try to make that seam break. As you can see, I actually break the model and the seam is still intact. That's important because if you don't have a strong enough seam, this happens. Let me bring it up. So one of the Rocketeers volunteered to build and fly this for me, and so here is his version of this model. So this is the hammer. Now this is a previous model, so I didn't figure out how to index the parts yet. So I made a coupler up top here with a launch lug. So you can see there's a little itty bitty launch lug there. And because the coupler is able to spin inside the tube freely, because the coupler can turn inside the tube, that lug is adjustable. You could put it wherever you need it. Yeah, CNC Kitchen just did a video on the differences that color makes with strength. It's pretty impressive. So this is the prototype model that he flew. He did a great job. It printed beautifully. You can actually see the outline of the ribs in the model. And his Prusa is limited to 210 millimeters, so I made 200 millimeter parts. But it was not a perfect success, because when the ejection charge fired, the parachute got stuck inside the model. And when the parachute got stuck inside the model, it overpressurized and blew apart the model. And you ended up with this. So you can see the part itself didn't fail. This plastic didn't fail. Nothing melted. Oh, no big deal. This is prototyping. This is what happens. You know, I'm thrilled that he was willing to spend, you know, $50 or $40 on motors. Probably less than that. Probably like $30 on motors, because he used F motors, F32 and an F44. Yes, I have takeoff video. We're going to watch that in a moment. But as you can see, this is the seam. So on, where can a good model, this is a bad model to show that. So you can see it here. One is different. See how that one seam is a bit thicker? It looks like a zit line. That's because it kind of is. That's where the nozzle goes from the outside through the tube to the inside and then prints the inside. Well, the seam failed. When it overpressurized, the seam gave way. That's why I'm testing this to destruction. That's why I'm trying to pull apart the seam. You can see the model actually failed between ribs, but the seam held, and that's what I need, because this is not going to fail in an overpressurization because the pressure's equal all around. The seam is the weak point, and on that model, the seam failed. Now, so here you can see here's the parachute. A little bit, that's a very heavy-duty parachute for this size model, and he just stuffed it in there too tight. We corrected that as well. And there is, now of course, once the seam broke, it came apart. Now remember, this model is not glued together. The only thing glued is these components. No, you can't randomize the seam. It's phase mode. The seam has to be continuous. That's one of the reasons why I make it a spiral, is that it shifts the seam left a little bit, so that as you go up in layers, the more solid layers seal the bottom layers. That's one of the reasons I do the spiral. There's a few mistakes I made, and I corrected all those, and we're going to go over that. So now, of course, once that seam blew apart, then the parts can come apart, because this model does not get glued together. The whole point of this model is that when you're done flying, you can disassemble it to its constituent parts and put it in the car. And then when you get to the flying field, you literally build the model on the spot. So yeah, you assemble the model and you screw all the parts together. Probably in a week or two, whenever he goes to fly next. I'm gonna let him fly this too, because a beta tester, he's gonna get all my stuff for free. But this is the Dragon that I'm working on. So now we go through debriefing. We go there. Here you can see the seam is what gave way on the model. Nice. Very cool. So the model actually held, this is the best picture here. The model actually held together perfectly fine. While that was tricky, I'll get to that in a moment. The model held up fine. The heat didn't bother the plastic, the ejection charge. I was worried about the ejection charge. Um, the It's just the seam that broke. Now, I don't think I actually needed to change my model. I think I could have left my model the same. Okay? Prusa Slicer has a weird problem. It's not really a problem. It's only a problem for me. Because I'm doing something. Hey, TRT. And hey, Newfound Drone. I'm doing something unusual. I'm making a very complicated phase mode model. And Prusa Slicer has a feature that conflicts with what I'm doing. And so I couldn't figure out why his parts weren't printing the same as mine. I couldn't figure out why he had to increase the extrusion multiplier so much to get it to work. And then I was like, I bet you this is adaptive extrusion. Prusa Slicer has something called adaptive extrusion. In Simplified 3D, we call it thin line behavior, and Cura's thin line behavior, but Prusa is a bit more involved. The Prusa Slicer will adapt the extrusion width to accommodate the model. And what I think is happening is that the Prusa Slicer, because my seam that goes inside the model and comes out, so all of these here, so these ribs do not penetrate the outside. They just touch the outside. However, one of them does penetrate the outside. It has to. You have to connect this surface with this surface. So one of these seams has to go all the way through. Is the autofocus going to play nice? Probably not. There it goes. Sort of. There it goes. So one of those seams has to actually go all the way through. And I think the Prusa Slicer was making that seam thinner because there's only a 0.01 millimeter gap between those two lines. There's a 0.01 millimeter cut going through the model. And I think it thought those are too close. But you're forcing me to print them because it won't print those gaps. I had to set the minimum gap distance to 0 just to get Prusa Slicer to slice this model. And now it's saying, okay, you're forcing me to print this too narrow opening, so I'm going to make the lines thinner. And I think it was causing the seam not to fuse because the adaptive layers was causing it to not print right. And then I kept having a problem with Prusa Slicer putting gaps in the model. You can't do that. Okay. Theoretically, you can do that. But if you want to try to figure out how to 3D model a ball and socket joint that has a 0.01 millimeter gap tolerance with a 6 millimeter thick wall, have fun. Now, there is a way I could do it if I don't use a spiral cut. If I use a straight cut. I'm using Prusa Slicer because that's what everybody else is going to use. Not everybody has Simplify 3D. It's a $200 program. So there's a lot of people, probably 99% of people don't have it, which means they're going to be using Idea Maker, Prusa Slicer, or Cura. Don't even think about trying to print this with Cura. Cura just fucking butchers it. You end up with this like riddled whole singularity space-time warp complex print when you try to print this with Cura. Forget it. It doesn't work. As a matter of fact, if one of you guys is really good with Cura, and if you can help me figure out a Cura profile that will reliably slice these parts, please contact me. But I was able to make Prusa Slicer slice these models no problem. Just every now and then I'd have this weird issue where Prusa Slicer would interpret a part of the model incorrectly, and it would cause a hole to form inside the model, and that could make the model fail. It would definitely make it weaker. And I spent dozens of hours just dicking around with Prusa Slicer, dicking around with Tinkercad, trying to get the model to be something that it would like. Eventually, it turned out to be an interaction between the rib and the outer skin, but I can't fix it. There's no way for me to fix it because the interaction it thinks is there doesn't exist. It just doesn't exist. And I finally think I figured out what was doing it. I figured out it has to be this adaptive extrusion. Like it's decided, okay, I need to make the extrusion too thin, so I'm just going to erase it. It doesn't exist now. And so it doesn't print that portion of the model. And I was like, and then the one guy says, well, slice is fine for me. And he showed me a picture. I'm like, how did you do that? He's like, I'm using 2.6 RC4. So I downloaded 2.6 RC4. I still had holes. And then I saw him mention, I made the outer wall 0.4 millimeters. And I'm like, what do you mean you made the outer wall 0.4 millimeters? Of course the outer wall is 0.4 millimeters. The nozzle's 0.4 millimeters. Kind of. There's no place to turn off adaptive extrusion, but I can override it. So in Prusa Slicer, you have, let me bring it up. As you can see, now the model slices with no holes. There'd be a hole right here and a hole right here. And I finally found out it is this setting right here. Hey, it changed it. How did it slice correctly? Unless it remembers it somehow? I don't know, but anyway, I just changed all these to 0.4 millimeter. So I changed default extrusion width, perimeters, and external perimeters. This is probably the only one I need to change because a vase print is all external perimeter. But anyway, I changed this, which should basically disable adaptive extrusion. I'm telling it, do everything at 0.4 millimeter. Don't argue with me. And then also this here must be set to 0. Slice gap closing radius has to be set to 0. Otherwise, my little 0.1 millimeter cuts, it corrects them and gets rid of them. I do that, and it slices the model perfectly now. No gaps, no holes. So that appears to have been the trick, and so far, all my models are now slicing correctly. So you can see there's just enough to give you this 2 merged layers for the top of the model, so it seals without top and bottom layers. Another trick I found out, it's a pain in the ass to do in Tinkercad, but it's not too bad. You'll notice that I don't have any right angles in here. They're curves. That eliminates the ringing problem. So I had a problem with ringing. You're going to see more about that when we get to the ramjet in a moment. But I had a problem with ringing, making the parts unreliably thread together, where you would put these parts together and they would not consistently thread together. See how smooth this is? See how nice and smooth that is? I kept getting a problem like this. This one's a really good example of this. See how the parts are kind of jammed together? That's because I lowered the extrusion multiplier to make it fit, but the ringing from cutting it on the outside and the ringing on this model, though you're hearing them hit. I see they just jammed right there. There we go. So you were seeing the ringing, and also this doesn't cinch because I made it too loose. So first, even though it's a royal pain in the ass, I did the work to cut from the inside out and not the outside in, even though outside in was easier. That means that instead of having, where's an example? I should have an example. Instead of having a part like this, you see here, let me switch. So you see how I have relief cuts in there? Come on, focus. So see how I have little relief cuts at all the cut joints there? There it goes. See how I have those little cutouts there? That's so that the ringing doesn't affect the diameter. But now that I'm cutting from the inside instead of the outside, I don't need those cuts anymore, so I got rid of them. But I want to make sure the inside fits well. So if this was a 90-degree angle here, if this was a 90-degree cut, this would bulge out here, and it would bulge out here. Yeah, I'm going to try to play with SolidWorks, because I think SolidWorks is going to be more reliable than Fusion. I don't want to invest the time to learn Fusion because Fusion keeps crippling the free version, and I sure as hell can't afford to pay for it. And the last thing I want to do is spend 100 hours learning how to do Fusion just to have them cripple the free version, and then I have to relearn how to do something else. So I'm thinking about either trying Onshape or SolidWorks, because you can do SolidWorks for $50 a year. They have a hobbyist license where you get it for $50 a year. And worst case scenario, I could download a cracked version. um, but so when you have a 90-degree cut here, the nozzle has to come to a hard stop, bang, and then turn right and go this way. And of course, you're going to have ringing. That's where you adjust jerk and acceleration, but you can never actually get rid of it, especially if you want to print in a reasonable amount of time. By making this a curve, two things happen. One, it doesn't stop. The printer doesn't have to go, what? Stop, turn right, go this way. Instead, it curves into the turn. And second, if ringing is going to occur, it's going to be in here, not out here. So it doesn't affect the diameter of the part. It also makes it print faster because it lowers the amount of acceleration and deceleration that it has to perform in order to print the part. So pretty easy to do. Once I make the little curve piece, I basically take a triangle piece, put two circle balls next to it, and cut out myself a little curve, and then I just tweak it until I like what I see. And then I just array it around using a master ring and then cut it into the model. Very easy. Yes, use your last name. I'm sorry. Your last name at Nerys.com. I was asking last week about that you said you figured out how to do this. Are you able to assign constraints? So, can I say, okay, I want you to put a cut from this wall to this wall. I want the edge to be conformal to the shape of this wall, and I want it to be 0.8 millimeters away. Can I set that up as a constraint? So I can just put a square cut in there. It'll shape it to the outside wall and move it, offset it 0.8 millimeters. Can it do that so that I can then take this part, scale it up and scale it down, and it will readjust the cut to remain conformal in 0.8 millimeters? Can your thing do that? Just don't post any fin cans to printables because unless you design your own, of course, then you can post whatever you want. Because I'm going to try to sell these. I'm going to try to make a little money. But yeah, can the build, and also where do I get build 123D? I couldn't find it. When I did a search for that, nothing came up. I assume it's not available yet. Hey, what happened to OBS? Oh, there it is. It got minimized for some reason. That was weird. But can you do constraints that I described? Yes, you can do constraints, but can you do that kind of constraint? So, for example, let me show you. Let's see. He said he's helping to develop it. So here's what I want to do. I want to you guys can't see what I'm doing. So I want to take a shape like this. Then I want to take a shape like this. Let's make this shorter. So I want to take a shape like this. And then I want to say, I'm doing this obviously using a model here because that's how I know how to do it. But obviously yours would be different. So there's my 0.01 millimeter. So I want to be able to say this. So I want to be able to do this. I want to be able to put this cut through this wall and instruct the program that this cut should conform to the external shape of this object. So fully cut the inside, but conform to the external shell, and then offset 0.8 millimeters. You might not want to piss off Autodesk. They have money. Autodesk has money, sadly. So I want to be able to do this. So cut this to be the same profile as the object, and then offset it 0.8 millimeters. And then I want to be able to array that around the model. And it's going to change as it goes around the model, because if you have threads, it's going to be different at every location. That's why it has to constrain to the outside profile and and offset 0.8 millimeters. So you can do that. Tom Stanton didn't do the wings right, though. I posted some suggestions to him. Here, let me show you how I did the wings. Well, his way worked, but there's a more efficient way of doing it, especially for manifold parts. Oh, how did I adjust the threads to get the fins lined up? Let me show you how I did that. Let's see. Let's come into here. Yeah, that's what I kept getting, 123D design. So build 123D should be fine. Especially since their product's discontinued. I mean, I love Tinkercad because it's visual. So it's WYSIWYG. What you see is what you get. It's object oriented, but it does have some pretty severe limitations when you start doing complex things. So let's grab this, and we're going to go into a new workspace so that I don't freak this thing out. Now that's cool. Because while I don't like the policies of Fusion 360, the program is fantastic. I see people make incredible stuff using it. Okay, so this is made up of two components. Oh, we're missing the launch lug. That's okay. We'll just stick something on there. Okay. So I want to print two of these, and I want to thread them together so that these two balls line up, because there's a ball in this one, there's a ball in the other one. So think of that as these two launch lugs. The way I finally, the problem is I have to make it repeatable, and I have to be able to build onto this without having to constantly print test models to readjust. So I realized that the trick was these two sets of threads. You have a set of threads in here, that's the female, and you have the male threads here. And these two sets of threads go together. So here is the parts. Oh, off by 180 degrees. Here we go. So here's the parts, and you see the launch lugs line up. So how do I print this so that this lines up with this? Well, the trick was trial and error. So I made a test part that just had a little fin sticking out of it like this. So it just had a little fin sticking out. Matter of fact, that's going to be a better way to demonstrate this. So I had a little tiny fin sticking out of the model, just like this. And I printed 2 of them, and I threaded them together, and I looked at the fins and said, okay, how far off are they? Now, each of these threads, each of these cuts is 22.5 degrees, and I was about 2 2/3 of those, so about 60 degrees. Turns out it was about 55 degrees. So what I do is I take this part apart, and you see there is my threads for the. What are you doing? Why would you do that? I clicked this. Thank you. So there is the cut that makes the threads inside the model. Okay. So I needed this to go this way 60 degrees, which means I need the body to go this way 60 degrees, which means I need to grab these threads and rotate them 60 degrees this way. And now I remerge the models, print it again, see how far off it is. I was about a degree off. So what I did was I was about 5 degrees off. So I printed one at 5 degrees, one at 6 degrees, and one at 7 degrees. And I was going to print all 3 and then see which one was closest and then fine tune from there. Turned out the 5 degrees was basically spot on. So I made it 4.5 degrees. So you'd have to tighten it a little bit to increase the tolerance. And that is how I did it. So I took the cut mold for this thread and kept adjusting, recombining, printing. I had to do 4 prints before I got it, which is pretty good. That's why I did such a small piece like this. Actually, I did an even smaller piece. It was literally just this section, this first 21 millimeters of the bottle. Do I have one here? No, I don't have it. But it was literally just the little tiny 21 millimeter piece. So it only took like 30 minutes to print. And so I would print it, adjust it, print it, adjust it. Once I got it adjusted, now I saved this part and this part together, and I just never changed them. As long as I do not move this piece and this piece, I'm good. I can move anything on the model. I can even move the model as long as I do not move them independently. As long as I rotate these 2 parts together as one unit, then I keep my alignment. And that's how I got them to line up. Now I know that if I align 2 parts the same way, so for example, I take this part here and I align it on the center line. So now this part is at 90 degrees. So now I can take and if I want the launch lug here, all I have to do is create a master ring and rotate it 45 degrees. And as long as I use that same 45 degrees on both parts, they'll still line up because I have not altered the relationship between this part and this part. And that's also how I got the fins to line up for the dragon. So that's how I did that. Now, he also had another failure where this shoulder right here, it separated. And I realized that I had broken my own model to make it easier to work with. So what I had done is I had made this model into 3 pieces. I'd essentially had this 21 millimeter segment with its own cuts. And then I had the body tube with its own cuts. And then I had this top section here. You can't see what I'm doing. So I had this bottom section with the threads in it as one cut. Then I had the body tube with its own cuts. And then I had the top thread with its own cuts. Now the advantage of that is I'm disassembling the model for you. So the advantage of doing that, let me change these colors so they're more obvious. The advantage of doing that is that I can now take this piece and put it on any model I want. But the problem is that essentially meant this piece had its own cuts and this piece had its own cuts. So there was actually nothing at all connecting this to this except the inside perimeter and the outside perimeter. That was the only connection they had. They were still vase mode compatible, but unless by pure luck the slices in this lined up with the slices in this, then these two parts were only connected by the skin. And that's not the way an integrated engineered structure is supposed to work. The skin is not where the strength comes from. The ribs is where the strength comes from. The skin just connects, the ribs connect the two skins together. So by not having the ribs a monolithic structure throughout the entire model, I created a problem where it could easily break where the two parts join together. So that's why I did this. You can see I have this big cutoff here. So what I did was I made one tube 400 millimeters long, and because that's about the biggest you're going to want to print one of these. And then I had the rib go all the way through top to bottom. And now if I want a shorter tube, what I do is I take this cut tool here and I adjust how long I want the tube. You can see I'm changing the length of the tube just by how much I cut off. But the result is I have one continuous rib going through. I have one continuous rib from the very top all the way to the very bottom, which means I have a monolithic rib structure inside this model that is not dependent on the skin to hold it together. It's one continuous rib all the way through. That's going to dramatically increase the strength of the model while adding zero mass. The other thing that I did was I made the tube thicker. So I made the wall thickness, the gap between the inside and the outside, 30% larger. I went from 4 millimeters to 6 millimeters, which is actually adding 50%. So that's a 50% increase in wall thickness, which doubles the linear length of the seam. So the seam I'm just reversing through everything I did. There we go. It's just doing the final merge, just waiting for it to do that merge. I've also learned that I have to simplify models in Tinkercad because some of my models get extraordinarily complex. And then, like when I make these ribs, I'm basically duplicating that complexity 16 times. And that could really fuck with Tinkercad. I haven't made this monolithic yet. But what I've done is I make my rib structure. I then export it as an STL. And then I re-import it as an STL. And that gets rid of all of the devolved history of the model. So now it's a single, simple part. And it's so much faster. Oh my God, it's so much faster. The difference is night and day. It's incredible. A limitation of Tinkercad. I still keep a copy of the broken apart model. So here, if we make this transparent. So linear length is the length here from the inside to the outside. By making this longer, you eliminate the paperclip problem. You know, metal fatigue, you bend a paperclip and you keep bending it until it breaks. Well, PLA is actually the same thing. If you bend PLA enough, it breaks. So do I have a piece I can show you? I should have something here. Do I really? Not. Oh, there's a piece right there. So you can tell when your PLA gets brittle. Come on. So it'll break, it'll snap, but if it's good PLA, it doesn't. It holds together. Now, if you bend it back and forth, let's get to a clean part. See, that's all brittle because it's been through the extruder already. There we go. So if you bend it back and forth enough, it eventually breaks. That's because PLA is very strong, but not very tough. It's a little bit brittle, and it can what we call is fatigue. So when PLA breaks, it doesn't give. It just snaps. Now something like ABS or PETG, they're nowhere near as strong as PLA. PLA is one of the strongest materials you can mess with without going to like Peak or Ultem. But ABS and... Are we good? There it goes. Because that looked like it was frozen. PETG and ABS are very weak. They're not nearly as strong as PLA, but they're tougher. And one of the aspects of toughness is when you bend it, it doesn't break. It stresses. You'll see the white stretch marks form in the plastic, and you have to bend it back and forth, back and forth, back and forth, back and forth, back and forth before it finally breaks. You also see this property with modified PLAs. So if you ever tried to snap a piece of silk PLA, good luck. The elastomers that they add to the silk PLA increase its toughness. So it becomes much more resilient. Silk PLA is one of the toughest PLAs you'll ever touch. The reason it seems weak is because its layer bonding is shit. So while the filament itself is incredibly tough, they don't glue together very well. So when you break a silk part, you're not breaking the filament. The filament is not what's breaking. What's breaking is the bond between the layers. And that's why you won't see me making a rocket out of silk. At least except maybe as a demo model. But if the wall thickness, that distance, is too small, then it's possible for the part to flex and break that seam. And before I realized that it was probably Prusa's adaptive layers causing the problem, I made the wall thicker to increase this linear length here of the seam so that it doesn't have that bending problem. Is everybody good? I haven't seen a post and this keeps freezing up on me. Is chat working? Are you guys there? There you go. Okay. Just wanted to make sure. So now the wall is 50% thicker. And it only adds, like, for example, I think this part, I think you add like 6 grams to the weight. So very small weight penalty. But it does create a problem. A good thing and a bad thing at the same time. The good news is, oh wow, that didn't line up right. Huh. It doesn't line up from that end. Why doesn't that line up from that end? Oh, there it goes. Oh, it's just tight. Okay. Okay. It was just tight. A little too tight. I'll have to look at that and make sure that model's okay. Now it's perfectly smooth inside. Where is my window? There it is. So now when you look inside, it's almost seamless. There's a smooth transition across the two parts there that you almost can't even feel. So that means my whole inside of my tube is nice and smooth. But that creates a small problem, which I have corrected now. I want there to be a shoulder. See, right now, when I built this model, when I build this model, this is the motor mount. Now the whole reason for this motor mount is to make it removable. So I can thread in this motor. And now this is a 29mm rocket. Now what if I want to fly it on a 24mm motor, or I want to fly it on a 38mm motor, or I want to do a cluster of 3 24mm motors? Well, I can unscrew this motor mount and screw in a different motor mount, which means it's modular. That's kind of the whole point. I want to make the rocket longer, add a section, just like that. I can just add a section. Make the rocket shorter, take away a section. Add an avionics bay, I can add an avionics bay. It makes it a very modular system. You can also dismantle it to transport it and ship it and stuff like that. It's pretty cool. And also, no glue. The only part that needs glue is the paper tube that gets glued to this. Now, if I'm going to have a motor that only goes to about here, then I don't need a C-ring. I don't need one of these. But I do need one of these. I need a thrust ring. Because right now, on a low impulse motor like an F-32, F-34, this is a non-issue. These engines are not strong enough to ever defeat this plastic. However, I want to fly this on genuine high power motors. I want to put like an I-205 in this thing and watch this bitch scream into the sky and tear a hole in space. Or put a K550 in here. You know, I want to put if somebody's crazy enough, I want them to be able to put a big motor in here and be able to say, see, you can 3D print them. But now you have a problem. Now you're talking about a high enough thrust where the only thing holding that model and that motor together is these threads. These threads and these ribs are the only thing holding this together. Is that enough? Probably. It's probably enough. My tolerances are tight enough that you're unlikely to be able to force this to go through this. And because of the ribs, you're unlikely to shear the ribs and force the motor through the model. But I would really like to have a second point of contact. I would like to have a second thrust plate. And the problem is I can't glue anything to the model. If I glue something to the model, it's no longer modular. You can't take it apart anymore. Now, on the original model, this diameter is smaller. It's easier if I take this apart and show you. So here's the original body section. And if you look in there, you can see there's a shoulder. Okay? The way this is designed to work, actually, I think this is for the, is this the new one? Okay, this is for the, yeah, this will work. So this fits in here. This is too small. This is made for a smaller model. But as you can kind of see how this cone shape will sit up against this shoulder in here, and it won't be able to pass through. It can come out this end, but it can't come out this end. And the idea is you would glue this and this to your motor tube, and when you screwed in your motor tube, this, which is glued to the motor tube, would push up against this shoulder in here. And now you have two thrust plates. Now the force of the motor thrusting forward is pushing against these threads, and it's pushing against that shoulder-to-shoulder interface at the front of the fin can. So now you have two centering points to center the motor, and you have two very strong, lightweight thrust plates to transfer the force of that thrusting motor to the entire airframe. The problem is I don't have that anymore, because I have to be careful how much I shrink this inside diameter. Because if I shrink the inside diameter too much, you won't have enough room for parachutes and recovery system and stuff like that. And I also don't want to make the rocket bigger, because that's going to make it heavier. I already went from 75 millimeters to 78 millimeters. So I added 3 millimeters to the outside diameter, and I shrank the inside diameter, and that's how I got that 50% thickness increase. But the inside of this went from 69 millimeters, which is the smallest opening at the top, to 66 millimeters. So I lost, 10% of my interior volume. So I don't want to add an additional shoulder here because now you're going to have more restriction inside here. I'd have to add beef to the inside of the model. So I don't have a second thrust plate anymore. I don't have a second point of contact to transfer the load to the airframe without glue. So I figured out how to do that. It's a two-part problem. For a simple model where you're only going to have the motor tube be about this long, so you only need the motor mount and a thrust ring. So the motor mount goes here, thrust ring goes here. That's not a problem. I can just make what I did here. So you can see, I now have a shoulder inside here. And let me flip it over, make it easier for you to see. So now I have a shoulder in this portion of the model, and I have a thrust ring designed to mate with this shoulder perfectly. I actually want to modify a little bit and have it come up straight here a little bit. I got to do that because that'll help center it better. It'll make it easier. It'll be self-centering if I do that. I didn't think of that. But anyway, that only goes in this portion of the model. That does not go in this portion of the model. Now, I did come up with an idea for how to add a centering ring to the rest of the model because now I have a problem. If I just add this motor mount to this tube section. Oh, that's the old design. That's not going to work. That's the old 75 millimeter. So if I add a motor mount to this model, and then this model has a shoulder that the thrust ring will sit up against on the inside, that's fine. Because remember, the thrust ring can't go out the top, but it can go out the bottom. Because the one part you have to glue is you have to glue this and this to the motor tube. So there's a paper tube inside here connecting these two parts together. And this entire structure can unscrew from the model and be swapped out. However, if I want to add another section to the model, and I want a centering ring inside the model, well, that centering ring has to be able to pass through the model to come out of the model for you to be able to disassemble it. This part here, no problem. When you unscrew this, the centering ring will pass through the model. Not a problem. But that centering ring cannot pass through that shoulder, which I don't know if you guys actually saw. That centering ring will not pass through this shoulder. And I can't make this shoulder removable. This shoulder has to be integrated into the model in order for it to act as a thrust plate. So how do I solve this? Well, I figured that out. I haven't actually done it yet, but I know how to do it. What I have to do is to make the centering ring a slip fit inside the model. So the centering ring will fit inside the model. And then the center of the centering ring will be two pieces that are threaded. So you'll have this little piece of the centering ring that's threaded and fits inside here. And that piece gets glued to your paper tube. So that when you unscrew this piece here and you pull this off, exposing the centering ring, you can then unscrew the centering ring from the motor tube, and now the whole motor tube can come out the bottom of the rocket, because now that little piece that's glued in the middle will fit through here. So the centering ring doesn't have to fit through here now. So that's how I'm going to solve that. I'm going to try to see if I can shrink these threads down to basically a skin tight piece that'll fit right over the motor tube. And then that would thread into your centering ring, and that would hold your centering ring in place. And then once you took off your body tube section here, exposing the centering ring. You would then unscrew the centering ring from the motor tube, and now the motor tube would be able to come out the bottom. So I maintain the modular nature of the rocket, and that was the goal. I want to keep the rocket modular, because there's just something cool about being able to assemble and disassemble the model at will to transport it. And I want to maintain that capacity. I want to maintain that ability to be able to disassemble the model and transport it. So this is done, although I still have to put a hole into that. Actually, I know where to put that hole. I figured out where it goes last night. It goes right about here. All right. Ooh, how am I going to do that? It's going to be tricky. I think I'm going to have to make a custom cut. Yeah, I need to make a custom cut just for that. All right. That's going to be a little tricky, but I know how to do it. I just got to execute it. Okay, so there is my pass through. That looks good. And that is not touching that cut. It's a little too close. So I have to put this little cut through here. This little thing. Actually, is that small enough to pass completely through that seam? That might be small enough. If I start here, does it still penetrate there? Yes, it does. I can do that. Good. I don't have to mess with that. Yep, that works. That works perfectly. As long as it passes through the full height of that, it's fine. Let's move that back a little bit. And we're still good. Okay. So now what I do is I separate this. And I take this and join it. This and join it. Yep, good pass. That works. As long as there's no gap, then it's still vase mode compliant. We're good. There we go. And now we join them together again. Because I used one single tube with one single cut going through it, I can now do things like this. As long as I position this in the same place with the same cuts, these two parts will line up and the cuts will line up and it slices perfectly. That was a nice little trick I found that allows me to add things like this to the model after the fact without having to redo all the cuts and slices. Oh, it's so much easier. It's so much nicer. So now when you print this, because see, the problem is when you put the motor mount in, you have a shock cord attached here. And you want that shock cord to go all the way through the model so that it can't rip out. But that shoulder is going to be sealed by the tube in the middle and the cone in the middle. So I need an opening in the tube here in order to allow the shock cord to pass through. I might move. This is not under stress because I really need that to be 1 over. I really need this to be over here, because that's where the shock cord lines up. I really need it to be on that one. And we are good. Clean pass. Because right about here is where this ends up. If I do this the other threads, you can see this, here's the, oh, did I do that wrong? I need to be on the other side. Yeah, it lines up almost perfectly with the next seam over. I'm on the wrong side. Yep, I'm on the wrong side. This needs to be over here. Verify we are clean. Yes, we are. There we go. So that spot right there is about where these holes end up when you thread it, and you want them to be relatively in a line. Otherwise, when the shock cord yanks, it'll try to twist the rocket, and you don't want it to do that because that could cut through the plastic. Basically, a radial zipper. You don't want to create a radial zipper. And the same thing when if you put a centering ring in your rocket, you need to make sure that the centering ring lines up with the other holes in the rocket so that the shock cord has a straight path all the way through the rocket. This way you don't get a radial zipper. Hi, kitty. Hi, baby. You want some loving? Yeah. You're like, give me loving. You can have loving anytime you want. So that works out really well. Now I have the hole lined up with where, right about there, with where the shock cord hole is going to be in the motor mount. Of course, it could be 180 off. The modeler will have to pay attention to that. So now it's 50% thicker, so my linear length for the seam is longer. We have fixed the adaptive extrusion in Prusa Slicer, so we should no longer get thin extrusions, which means we'll get better fusion along the seam line. And I've also made the ribs a monolithic one-piece structure going through the entire part top to bottom. All of that results in a substantially stronger part overall. Now, the reason I make the ribs a spiral, besides the fact that it really looks cool, is that now each tube section has multiple points in contact with the rib. If I have the rib should be a little bit more aggressive, but then I'd have to design each piece individually, and it's not worth it. You also can't make the rib too angled, because then each layer is technically an overhang, and you have less bonding strength between them. So you don't want too much of an angle, because you want that good, strong bond, because that's what's holding this together. So this should work. It should be the last change I need to make, besides fine-tuning and tweaking. And now that Prusa Slicer can slice it correctly, anybody can slice these models. They'll just have to consult with me if they're unsure about making sure it's strong enough. And the only thing you should have to adjust is extrusion multiplier. So if you're in my Patreon, you've got access to the files to download if you want to try printing this. If you are not a Rocketeer, if you do not fly model rockets, be careful. This is a prototype. Okay, so, and rockets of this size can hurt people. They do 300, 400, 500, 600 miles an hour, and it can hurt people, including yourself. So if you don't know what you're doing, don't do it. If you just want to print it for a display piece, great. You don't need to print the thrust ring. Just print everything else with all threads together. But if you want to actually fly it, work with a club, work with other people if you don't know what you're doing. Now, if you are an experienced Rocketeer and you want to beta test, please contact me. You don't even have to be a member of my Patreon. If you're an experienced Rocketeer and you're willing to fly it within the next 30 days, you'll have to buy motors and parachute and shock cord, and of course plastic. But I will provide the files for free, and I'll give you personalized one-on-one help in making sure they print correctly. You got to make it stick to the bed, but I'll help you with making sure the part is, strong enough to be correct, and we'll make any tweaks or adjustments that we think we need to make it work correctly. But I need like 10 different people to fly this and make sure it works consistently on different people before I release it as a kit. The hammer is going to eventually be released for free, because I just have that. Maybe it's dumb, but I have that open source, pay it forward mentality. So that one's going to be free. But everything else, I'm going to sell. So the Dragon that I'm working on next, that one's going to be a paid model. And go from there. I might even make the free one a simpler model, with simpler fins, because those are kind of pretty cool fins on the hammer. So I might just make the, just these fins. Yeah. I might make it just, simple fins like this. And they kind of look cool. I like the way they look. So I've been working on other models as well. As you know, I'm also working on a glider. But I'm also working on another rocket that I really like called the Ramjet, which has a really interesting feature where it looks like you have vane structure inside the model. So let me bring up a picture and show you what it looks like, and I'll show you how I made it in 3D. So this is the Estes Ramjet, and it's a really slick looking rocket. So basically there's a tube going up the middle, that's the actual rocket, and this outer shell is just basically decorative. So you got these two larger outer shells, and then you have these vanes inside here. Oh, I just realized those vanes are tilted inward. I did not realize that. Ooh, I can't phase mode print that, so mine will be a modified Ramjet. You can see the center section's open here with some vanes, and you got some vanes in the back, and you got some big fins. So I had to make a tube, and a set of vanes. Now the paper tube will glue inside of here, and then this, I actually made it so it slots right into the tube like this. Just like that. And then the other tube slots into that. And now you have that Ramjet look. You have the two tubes with the little vanes in the middle. And then there'll be, this is too small, but there'll be a vane piece sticking out the bottom. Actually, that'd be just about right for the top. Yeah, that's just about perfect for the top. Ooh, that's too weak. I gotta put more. Oh, this is under extruded. That's right. So you have your vanes at the top, your vanes in the middle, and you'll have another vane section at the bottom. And I can even hide the launch lugs. So the launch lugs are hidden in here, and there'll be a third one down here, so you won't even see them. The launch lugs will be hidden inside. That's pretty cool. Of course, nose cone. But these parts all fit together. Let me tell you, this was such a bitch. I finally figured out how to do it using the same technique I used to get rid of the ringing, because the ringing is the problem, to get rid of the ringing on my phase mode parts, because these are all phase mode printed. Instead of having a square fin come out, the end of the fin is radiused. So you still get a little bit of ringing, but very little, because now it's not drawing a square. It's not going dink, dink, dink with ringing on the two corners. Now it's doing a loop, which is significantly smoother. And the moment I did that, it just fit like a glove. So I am super stoked by that. But then I was kind of sad because this you can see the orange tube actually has a silver trim ring for here. And I can't build that into the vane piece because that would violate vase mode. That won't work. And then I realized I can just print the trim ring. So now you take your model and you first put this on. This needs to be made taller. But you put your 2 trim rings on. And now you have your silver trim rings on the orange. Now, why is this important? Because you don't have to paint it. Because this is a 2-color model and I'm able to print the individual pieces, you just print these parts in silver, you print these 2 parts in the fins in orange, and the model prints in the color scheme that you want without having to, paint anything. You just need to get a set of decals and put on it. So I need to finish these vane rings. Make this one needs to be a little bit bigger, and of course I need to make this one bigger so it's at the bottom. And the other cool thing I came up with was, how do I attach the fin to the rocket? I can't design the fin into the model because the fin sticks out the bottom. And that won't work with vase mode. You can't vase mode this, okay? So I can, however, vase mode the print fin by itself. So the fin prints just like this in vase mode. You have all the reinforcement ribs. Now originally, I made like an aerodynamic little socket on here that this would fit into, because I can't just glue this onto the side of this. That's not going to be a strong enough bond. You need a little more integration than that, because this is going to come down and hit fin first. I'm going to recover it backwards. I'm going to put a hole right here in the back of the piece in the back here, and I'm going to recover it nose first. So the nose cone's going to call, there's going to be a string running down the length of the model on the outside, and it's going to flip over and come down nose first with the fins up in the air. This way the fins aren't going to whack the ground and break when it lands. But also, I still need them to be stronger. So instead of making a big ugly socket that definitely does not look scale, I realized I could make an invisible socket and it would actually be stronger. So this is a rib that's 3 layers. It's rounded and beveled on the top, and it's got a bevel on the bottom. The bevel on the top is so you don't have a hole, because hole equals weakness. So that bevel reduces it down to 0.8 millimeters, so it seals without breaking vase mode. And then I can't start printing a straight out piece, but I want that piece to be straight out for fin alignment. So I put a little sliver in there. Now normally you couldn't vase mode print that sliver on this part, but because it's at an angle, that sliver is actually straight up and down, which means it's completely vase mode compatible. So I have a little socket designed into the fin that's fully vase mode compatible, and I have a little stub on the fin. Now this doesn't work perfectly, and I haven't figured out why yet, but this is actually curved to match the body, and the idea was to get a near seamless joint. So what you do is you put the fin in the socket, push it up to lock it onto that stub, and then you have to glue it. This is not going to stay there. You have to glue that. But there, you get an almost seamless joint to the body. And because you have 4 layers of plastic, actually 5, you have these 3 walls here, and you have these 2 walls here, plus this surface mating to this surface, and the result is an incredibly strong joint. Once this is epoxied on here, this is going to be a very strong joint. It should not break. Although I might increase the number of ribs. Although, no, again, this is weak because of the under extruding. I wasn't extruding enough of the PET. I didn't realize I had to increase the PETG 5%. And that results in this being, you can actually hear it, it's a little crunchy, because it's not fully integrated. So once I increase the extrusion multiplier and reprint this, that'll work fine. And that also might tighten this up too, because that's a little loose, and it shouldn't be that loose. So when I increase the extrusion multiplier, that should tighten up that connection as well. But yeah, that came out great. Of course, these will be printed in orange. But this is just, it's turning out absolutely beautiful. I love the way this model's turning out. It's basically no painting required. You just print in the appropriate colors, and all the parts, oops, that's the wrong end. Oh well, it doesn't matter, you get the idea. This is supposed to be up here. Actually, I can swap that easily enough. That fin wants to fall off. It really wants to fall off. Oop. This goes in here. There. So 3 fins. This is going to be a little bit bigger. This one's fine. This one's going to come out the bottom here, and you'll have that model 3D printed. And then I can also scale this up to this size. All I got to do is increase the size of the model by 50%. I might need to change this diameter of the hole in the middle here. And then this will print 50% larger, and I can print it with a 0.6 millimeter nozzle. This is 200 millimeters, so it'll be 300 millimeters at 50% larger, which means it'll still fit on that print bed. Everything still fits. Same thing here. This is like 180 millimeters, but it takes up 200 millimeters because you have to count this tip here. So from this tip to this tip is 200 millimeters. So when I scale that up 50%, that's 300 millimeters. But Pythagorean's theorem, a squared plus b squared equals c squared, I can print a diagonal part on that print bed at 530 millimeters. But because I made it 200 millimeters and now it's 300 millimeters, I can still print it like this, which means I can do 3 of them in sequential print order without having to print one at a time. I can do all 3. So definitely going to do that. But yeah, this is cool. This is coming out really, really nice. I'm actually kind of more excited to fly this. This is going to fly on D motors. You know, a D12 should be enough to lift this. It's not going to be that heavy. I hope a D12 will lift it because that's what I want to fly it on. I want to fly this on D12s. Although I think this, yeah, I made this for 29 millimeter motor tube, so you can fly this on 29 millimeter. This is a thin tube, so you say, well, what about the seam? Well, remember, this is decorative. The tube going up the middle is what's going to have the motor in it. This will never experience pressurization for ejection charge, so I won't have to worry about the seam breaking. But yeah, that's really cool. And I also love the fact that I was able to hide the launch lugs inside. And indexing is easy because these 2 parts are identical and these have vanes, so they self-index. I don't have to worry that they don't thread together. This is not designed to be modular. This model needs to be glued together. But it's self-indexing because these 2 parts are identical and the vanes are identical. So they see it in there. The launch lug will be there. And then the piece on the bottom will have a single launch lug that'll be hidden up inside here. And those 3 launch lugs will line up, so you'll have a hidden launch lug to fly this. This is pretty cool. Now I realized that I can also do this little peg. I kept the tools that I used to make these stubs, so I can put these stubs on this model. So I can make one of these with 3, 4, 5, 6, 8 of those stubs on it. And then you can design whatever fin you want. And as long as the fin is large enough to be able to fit this. And of course you can change the size of the stub. I'll probably have a short stub and a long stub. And then I'll probably also have, I'll probably do 3. Short stub low, short stub centered, and then long stub, so that you can have the fin, mount here, or you can have the fin center mount, or you can have a big fin that's as tall as the tube section. So that should cover 95% of fin designs, and then you just need to design yourself a fin. Use the cut tool that I make to put the hole in that fin. I'm gonna have to build the curvature into that cut tool. So you align that cut tool with your model. Just make sure they overlap a little bit. Even if it cuts a little bit of your fin off, it's fine. But you have to get your model in, you know, the fin in this orientation, and put that cut tool there to create that so it'll attach to the standardized stub on the rocket. And this way people can design their own fins and attachments. SRB attachments, fin attachments, ring attachments, whatever you want. I mean, it's the I would like to make a truly modular so that the parts would slide together, but that'll come later. I gotta figure out how to do that. When you're dealing with bigger rockets like this, flight stresses become more of an issue. Hey, that brim came off pretty easily. I'm impressed. I have to use a double layer brim, and I had to make this the bottom of the fin a couple of millimeters wide. Otherwise, it just kept flexing and not printing correctly. Another thing I'd like to do is on this fin, the straight lines look kind of cool. It gives it that industrial look. But I'd also like to make the a zigzag fin that goes back and forth gently, not that big a zigzag, like, you know, ding ding like that, so that the chevrons and they overlap, and that'll do the same thing as the spiral cut in the tube. That will make this stronger, but this is pretty damn strong. I mean, the only place it's weak is if you bend it like this. This buckles in between the two vanes. The zigzag or tilted vanes would take care of that. I could do tilted vanes on this. So this prints like this. If I were to print this straight up like this, I would create a cross pattern that would help with that a little bit. And I might do that. I might try that, because that would definitely help with the structural integrity of the part. But this is way stronger than the equivalent balsa wood fin. But I'd like to get rid of that flex between there, and angling these relative to the grain of the plastic would do that. It would integrate it better, just like the spiral does on the just like the spiral pattern does on the tube here. See a spiral pattern. So, but from a Rocketeer's perspective, straight lines look pretty cool. The angled lines look kind of odd. If they were hidden inside, that's fine. But if you can see them, they're kind of odd. But, either way, now you could also, if you wanted a cleaner model and you didn't mind it being heavier, you could print this with infill. And this way you'd have that clean outside skin. You could do that. But I want to print vase mode because I want light. I want performance. That's basically caught up to where I am. I am still working on the glider, so I can show you guys how far I got on that. So I got a one-piece tail now, and a one-piece nose. This is the wrong nose. That's the wrong. Well, this will work. That glues to that. That's the fuselage, and then there's a nose cap. That friction fits on the front of this. That's the small one. That one's too small. I got to scale that up a little bit. And then the wings. Are these the new wings? Yes. That wing. This wing. Fit into here. And that. This is the big one. But that's the vase mode printed boost glider I'm working on. And there'll be a little mount here, a little hook that hooks onto the rocket. So your rocket would hook on like that, except be long and skinny. It's gonna be designed to boost on these. It might have its own dedicated booster for the small one, but this one should boost on the 3-inch. I want to try printing this with a 0.4mm nozzle, because that'll make it 50% lighter, and see if it's still strong enough. I'll have to do some changes to the model for the gapping, because the gaps are for a 0.6 nozzle, so I'll have to alter the gaps, but that's not that hard. but I want to try to print this for a 0.4 millimeter nozzle, but this size, and see how it works, see how strong it is. Because boost colliders don't need to be that strong. I mean, most boost colliders are made of thin balsa. They just need to be stout enough not to flutter or come apart under boost. But beyond that, they don't have to be that strong. So I probably don't need to print this with a 0.6 millimeter nozzle. So I may rejigger this to not do that. Now that's one thing. I can show you how I do the wings differently than Tom Stout did it. Makes a more integrated structure. So we're going to switch to a orange wing because that's easier for you guys to see the inside of. So you can see the vein structure inside there. Now that vein structure penetrates this side, but it doesn't penetrate this side. But there's a little trick. That's why his was so floppy until he glued it together, because he went all the way through. Let me show you how I did that. Tinkercad has no automated process to do this. No, I have not done anything with the crown molding. Oh, you got a good point. Although come springtime, I'm gonna break out the CR30 and I'm gonna try to set up the roller beds. I have two 10-foot roller beds, so 20 feet of roller bed, which means I'll be able to print 30-foot objects while being supported. That's going to be fun. So I do plan to do that. Although the problem is I already have crown molding, so changing this crown molding for generic 3D printed crown molding doesn't make any sense. But if I can change it for something cool, something nice, especially in something like a nice silk, like who makes that real nice silk, that midnight blue? Oh, what's the name of the company? They almost went out of business, but they managed to keep it together. I think their official distributor is Printed Solid. Let me bring up that wing. Somebody asked about the wing. The 123 CAD guy, John. Let's see here. We are on the next page. There it is. No, that was I want to say Sunlu, where they screwed up. I don't see how PLA. Well, okay. When you say creep, I think you mean the wrong thing. I think you mean it'll droop over time. No, that's not the case. PLA does not do that. Now, PLA can distort under load. So, for example, if I were to attach this to the wall and then put a weight on the end of this would eventually bend. Now, this might not because it's a three-dimensional structure, so it's going to hold up to more. But if you were to print a simple slate of PLA and like a bookshelf, and you were to put weight on it, if you don't have support under here, it's eventually going to bend. Okay, that's not creeping, that's bending. The material is distorting, it's bending over time. However, crown molding is not under load. It's because I'm actually designing the nail holes right into the design of the crown molding. So the holes will already be there for the nail, so I won't have to punch a hole through it. I won't have to drill. It'll already have holes, and you just put the nail through it. But there's no load on this. Why can't I figure out the angle? There's no load on this. There's no weight on it. There's nothing pulling it down. That if you printed that out of PLA, it would stay forever. Now, the only problem you might have is if you ever sold this house and then you depowered it. Like when I bought it, this house had no power for like 10 years, 15 years. Because obviously the bank's not going to pay to have electricity on a house that hasn't sold yet. That's up to the new person to pay to reactivate the electricity. So in the summertime, this house could get pretty hot inside, and it might get hot enough inside for PLA to reach its TG temperature. But even if it does at that light of weight, I doubt it would be a problem. But as far as the bending over time that PLA has a problem with if you put weight on it, that doesn't apply to crown molding because there's no weight. It's being held up by nails every foot or so, and between the two nails, there's no weight pulling down on the crown molding. And even the entire length of crown molding just doesn't weigh very much. I mean, you're talking, a 20-foot length that might weigh a pound. Not even. It might weigh half a pound. Yeah, 2.2 pounds per kilogram. And I figure I should get, 80 feet out of a kilogram. Yeah, that's not a problem. That's not a problem at all. Especially if I use a larger nozzle. Like I'm probably going to use a 0.8 millimeter nozzle. Not so much because crown molding needs to be that thick, but it's a hell of a lot easier to print. So, yeah, that won't be a problem at all. You won't have to worry about creep for something like that. Anything sticking out cantilevered with any kind of mass on it, yes, you have to worry about it bending over time. But that is not a problem. And I'm probably still going to print a piece of gutter just because I want to. There's no cost-effective reason to. I can buy gutter for cheaper than it costs me to print it, even with free plastic. The electricity to run the printer will probably cost more than the gutter. Probably not, but the gutter is that cheap. It's like $5 for 10 feet. It's stupid cheap. I didn't realize gutter was that cheap. But I'm still going to 3D print the mounts for the gutter because why buy them if I could print them? I certainly have plenty of this. Now, gutters are under load, but they're only under load when something's in them. So in the summertime when it's raining, yes, the rain's going to be heavy, but the rain's going to flow out. So they're not going to be under continuous load, so that won't be a problem. Snow could be a problem, but the plastic is also going to be more rigid when it's cold. So again, I don't think it'll be a problem. But I'm probably going to print the 20-foot piece for my carport here, just because I want to print something 20 feet long, just because I can. No other reason, just because I can. It'd be a fun project and a fun video, so that's the only reason I'm going to do it. And now of course when I gutter the rest of the house, I'm just going to buy the gutter. It's silly to print it when you can just buy it. And but anyway, the wing. So I wanted this crosshatch pattern for strength. That makes the wing rigid in all dimensions. This way, this way, this way, this way. In all dimensions, this wing is nice and rigid because I have a 3-dimensional shape with a 2-dimensional crosshatch pattern going through the wing. And that gets you this. But there are a couple of conditions in order to maintain vase mode compatibility. You have to be careful with these lines intersecting the outside edge of the model, because if you intersect the outside edge of the model, you create an island separation and you break vase mode. Also, these cross lines can't intersect. You're not allowed to have an intersection in vase mode. If 2 cuts intersect, you've created 2 islands, and you can't do that. So I had to take my cross pattern here and cut off the line going this way and cut off the line going this way to create this zigzag. And then I had to separate this zigzag by a little gap to make sure I maintained vase mode integrity. So by doing that, by the top and bottom can go all the way, although I made this one stop short so that I can close the end of the wing with top layers. Just makes a cleaner wing aerodynamically and handling it. Otherwise, I just cut away. I don't let them go all the way to the edge. Right? The edge shape itself provides more than enough strength there. It's okay if there's a little gap there. So just don't let them go all the way to the edge. Don't let them go all the way to the edge. And then make sure you create this crosshatch pattern. So you can see I got this zigzag here. So it goes this way, then this way, then this way. And then this one goes this way, then this way, then this way. This one's a partial, and this one's a partial. So basically, once I created one of these zigzags, I just took this zigzag and I flipped it 180 degrees. I did a mirror flip to make this one, and then I mirror flipped it again to make this one, and then I mirror flipped it again to make this one. And then I just cut off the parts that I don't want to get in the way, and I made sure to separate them by a small gap. Now, it's important to realize that they do not come through this side. You can see this side's smooth, this side is cut. So the way that works is this way. You can see the inside of the rib structure here when I make it transparent. So the way I do that is the same way I do the body and the same way I do the everything else. I can show you how I do that. We are already pretty much set. This is why if he can teach me how to do this in the CAD program, it would be so much easier. Oh my God, would that be a blessing if I could even just semi-automate this process with constraints? So here's how I do this. So I want to create a rib in this cone. And I want that rib to not touch the outside. The inside doesn't matter because it's going to penetrate the inside. So here's what I do. I make this a solid. And I take this and I put a box over the rib like that. I make the box as tall as the rib, and I make the box come all the way inside, but it can't penetrate the inside. So you can see here, it penetrates the entire outer skin, but it does not penetrate the inner skin. This requires a little bit of effort if your object isn't the same shape all the way down like this one is. So if your object isn't the same all the way down, that creates a problem that you have to address. But that's more complicated. It becomes obvious how to fix it later. What I then do is I take this yellow cone, move these parts out of the way. Show you this. There we go. Without making a bigger mess. I got a ton of parts sitting here. I take this part here, I Control D it to make a duplicate. I turn it transparent, and then I combine it with my red block. Now that I've done that, I'm going to temporarily move this so you can see. Now you can see this red block has the shape of the outside of this cone. Okay? Now I turn the block transparent, and I combine the block with my cut. And now my cut is conformal to the outside of the cone. Now I take that cut, I hold down the Shift key to restrict myself to X and Y only. So I'm going to translate it on one axis only. Hey, Drone Shots. I hold down the Shift key, I translate it left. You can see here, because I held down the Shift key, this is a relative movement. This is saying I have moved this part -3 millimeters from its last location. I click that and I type in -0.8, 2 times my nozzle diameter. I now have a cut that is conformal to the outside surface, and it's 0.8 millimeters from the outside surface on every single layer. I now need to array this around the model. If your model is symmetrical, you can just array it. If your model is not symmetrical, you have to create an independent cut at every single location. That's what I had to do to make these on the inside instead of the outside. Pain in the butt, but if you do it right, you only have to do it once. I now need a master ring. So I'm going to drop a master ring in the center here, a torus. I'm going to make it bigger. It just has to be bigger than the model. Okay. I then select both the torus. First, let's make the torus more sides. I select the torus and the cone. I align them but I hold down the shift key and I select the cone because I don't want the cone to move. The cone cannot move relative to the slice. I have to move the master ring to align it with the cone. There. Now the master ring is aligned with the cone and the cut is aligned where I want it with the cone. Now I select the cut. I hit Control D. Being very careful with your key presses here. Hold down Shift. Select the master ring. Now you have both parts selected. You have to do this in one motion for this trick to work. You grab your control handle here and you stay on the inside of that ring and it will jump to a 22.5mm detent. Bink, let go. That's it. You're done. Now hit Control D again and it will repeat that operation. Control D, there's another one. Control D, there's another one. And just keep doing that until all the ribs are formed. There, I have all my ribs. I'm going to take one of these master rings, I'm going to hide it, and then I'm going to highlight the master ring again because there's now 16 master rings. It got duplicated with the rib. Delete them and then bring back my original master ring. You want to try not to have dozens and dozens and dozens of parts in here because Tinkercad slows down when you do that. Okay. Now I need to take this part here, and because one of these ribs has to penetrate the outside of the model, and I'm just going to move it right 2mm. There you go. So now these ribs are all conformal to the shape of this cone, and they are exactly 0.8mm away from the outside edge of the cone at every single layer, and this one rib fully penetrates the outside of the cone. Now to make this easy, I'm going to grab my yellow cone and I'm going to hide it so that I can select all of these and only these, join them together into one, and turn it into a hole. Now, there's an extra step. If you're doing a really complicated model like this, there's a step that you can take to simplify the model for Tinkercad so it doesn't throw a conniption fit. What I'm going to do is I'm going to take Brave Trug and I'm going to export it as an STL. Because these are simple faces, they should export and import cleanly. And then I'm going to re-import the file I just exported. There you go. Now the advantage of this file here is it's simple. This file is complex. It's made of 16 pieces, and each of those 16 pieces is made of 3 pieces. 4 pieces, actually. It's made of the cut, it's made of the cone, and it's made of the square, and the square is also made of the cone. So you're taking what is 64 pieces, which is a lot of work for Tinkercad, and you're reducing it to a single piece. Because you notice this I can break apart. This I can't. This is a simple object. This is a complex object. Now, because these are both on the 0 plane, I can actually lift this up to make this easier. And I'm going to take that piece, select it, take this piece, select it, align, select this piece, and align it with that piece. There. Now it's in the exact same position. And this I'm going to save, but I want to save it with the other piece. So I'm going to hide that other piece for now. I got to bring this back down to 0. I got to bring back my cone. I got to select both of them, Control D, and put it over here. Now I can delete this copy, turn my simplified model that I imported into a hollow, and I can join them now. Watch how fast it joins. Boom, done. Because it's a simple model. All right. Now, the reason I kept a copy is if I ever have to edit this, let me get rid of the simple copy in there. If I ever have to edit this, I'm going to want this to go back to because this is editable. This is not editable because it's a simple shape. that I imported from an STL. Now, the reason I copied it with the cone is because the cone is symmetrical. See, 7943, 7943. This, however, is not symmetrical. 7783, 7983. Both dimensions aren't the same, which means if I were to try to center these, you can see they're not going to center. See how it's black instead of gray? It's centered this way, but it's not centered this way because this piece is sticking out. So it's asymmetrical. So in order to be able to center this, I need to be able to put a master ring around it, and I need something with which to align the master ring. Since this part is symmetrical, I can align the master ring with this part. Now it's symmetrical. Now if I take this piece, let's turn it back into a solid, I can now join this piece with the master ring. And now I can move this as one unit. And now this is symmetrical. 9551, 9551. Which means now I can center this in this using a simple center command. And it will be in the correct position. And when I'm ready to perform operations, I simply uncouple them. Boom. Now they're uncoupled again, and I can turn this transparent again. So whenever I want to move this, I just couple it with something bigger that's symmetrical, the master ring. And now I can move it, do things to it, and recenter it in the model. If you don't do that, you can't recenter it. Watch what happens. If I take these two parts and I center them, see? Now they're penetrating this side, and they're too far away on this side. That's because it's not symmetrical. The master ring fixes that problem. So now I have a cone with ribs. And those ribs are 0.8 millimeters away from the outside, which means you'll get that unified fused structure, except for the one which goes all the way through. And now if we download this and bring it into the slicer, now it slices cleanly in vase mode. See? No gaps, no holes. And if you bring down a couple layers so we can see, you can see how these layers just touch the outside, but this one penetrates the outside. So there's no retractions, there's no travel moves. And if you zoom in, you can see these touch, or close enough that when the plastic gets near it, it's going to fuse together. If you see an obvious gap, boy, these programs really suck when it comes to trying to move around in 3D space. So you want to make sure that these actually, fuse together there. There we go. See? They actually, that's the gap. But there it is. You want to make sure that there's no gap in here. There's no space in here. And now this will print cleanly. All vase mode. So this part will only weigh 20 grams. It is 80 millimeters tall, or 80 millimeters wide, and 51 millimeters tall. So this is not a tiny part, and it only weighs 20 grams. While if I were to print this normally, so if I were to print just the cylinder, for example, let's bring it into Simplify. I'm better with Simplify 3D. I can manipulate it faster. Okay, so if I were to bring this one in here and slice it, there you go. It is 18.47 grams of plastic, and we see no, let's try to turn on. There we go. So there's no red lines where there shouldn't be any. There's no bubbles where there'd be retractions. And when we scan through the model, we see that tool does not jump. See how that tool stays in the same relative position all the way up and down? That means that tool never jumps and moves position. And that's what you want to see for clean vase mode. And this will print in 1 hour, 36 minutes, and it weighs 18.5 grams. Now, if I were to take this exact same cone, and let's say I printed it with no top and bottom layers, just 2 perimeters, even though I don't know if that'll be strong enough, we're just going to do 2 perimeters. Let's do a lightweight 10% infill. And I think that's it. We don't need top and bottom. 10% infill. We should... Oh, I got to turn off vase mode. And now we print this. It's going to take an hour longer to print, and it's going to weigh 8 grams more in plastic. And that's with a very light 10% infill and only 2 perimeters, which should be about equivalent in strength, but it won't be as light. So that's, you can see it's very simple infill, but because you have to fill all this space, you end up with a whole lot more mass than you need. And of course, you end up with these zits all over the model. And you just don't need any of that. So just by taking that exact same cone and putting all the cuts in it, going single perimeter vase mode, we lose over 8 grams of weight. We have a flawless, a near flawless surface. You say, well, wait a minute, you still have that cut. Yeah, but you're still going to have a zit line. Whether it's random or straight, you're still going to have a zit line. My line here will be less noticeable, and on top of that, it'll be strong because there's no breaks. This is one continuous piece of plastic all the way up, top to bottom, one continuous piece of plastic all the way through the entire model. The extruder never stops. The filament never stops. It never retracts. One unified structure that uses a whole hell of a lot less plastic. And as you get more complex, you use even bigger savings. Even just this piece alone, it's an hour difference in print time. That's huge. That's such a huge difference in print time. But yeah, it's fun. It's a lot of fun to do. It's a lot of work, but you get really cool models when you're done. You get just absolutely beautiful unified structures like this, where the whole thing is just one beautiful unified structure. And when you really nail it and you can make things thread together. Off by 180. There we go. And you can make things just beautifully go together like that. There's just something cool about that. Do I have a motor mount here? I don't think I have a motor mount for this class. Yeah, I don't. But it's just cool to be able to do that, to be able to make parts fit together like that. And flawless. Except for the seam, this model is virtually flawless. There isn't a single zit anywhere on the entire model. No zits whatsoever. It's one unified piece that's all integrated and structurally sound. It's cool. Come on. Stop messing with me. All my parts keep moving. And then, of course, you can start doing crazy cool things with cool plastics like this. Heck, actually, I just realized this is that same back model. I can do crazy shit like this. Oh yeah, this is gonna be good. This is gonna be good. That's just good. Oh my god, that's good. And then here's the motor mount. There you go. That's an interesting model. You're going to need a lot of tubes up here to make that stable. That's just great. But that's the modular nature. They all fit together. All these parts can go together with each other. Oh, yeah. That's just fun. I can take that off. I can take this part out of here. And I can put this part in here. And because it's all modular, it all fits together. That's just fun. This is a recreation of my level 2 rocket, downsized, where I use through the wall tube fins. I just made a 3D printed version of it. That's just fun. That's just cool. Any other parts I can slap on here? Nothing handy. That is the new style. That's the new version. Yes. But that's just fun. I'm trying to get that Vision Miner guy to I would love for him to print me a hammer in Ultem 1010. That'd be an expensive print, so I don't know if he'd want to do that. But it would only take like half a kilogram, but that's like $100 worth of plastic. But I would love to have one of these printed in Ultem 1010. So you'd have a semi-transparent rocket where you could see all the ribs, but it'd be a material that's virtually indestructible. Like you could crash it into the side of a building and it'd be fine. It'd still be soft and pliable. That would just be fun. I thought it was also pretty cool to make the motor mount red. Flame, fire. So that's yeah. Being able to swap the parts is just, it's fun. But yeah. A lot of fun. So I guess that's it. I want to go grab that turkey outside. It should be thawed by now. And we're gonna have turkey again tonight. I'm addicted to turkey. I don't know if you guys saw, but I made homemade beef stew the other day. It came out so good. Oh my god, that came out so good. I'm definitely making that again. We're gonna up the meat content a little bit though. I like my beef stew meatier, and it's expensive as hell. I mean, the beef stew cost no, I have a rotisserie. I still have my Showtime rotisserie that's from 1998. So my 25-year-old rotisserie still works. We paid like $700 for it because we got all the accessories, the extended warranty, everything. We bought it for my dad for Christmas because he used to be a chef, and so he loves cooking, and so he loved it. He absolutely was thrilled by it. We use that so often. It's crazy how often. Oh my god, it's so good. Oh, I buy those little 3-pound, $14 turkeys from Walmart. It's boneless and skinless. You just cook it, and I let it thaw, and then I cook it for an hour and 10 minutes in the rotisserie. 50 minutes not enough. It's still raw in the center, but hour and 10, hour and 20 minutes, perfect. And it came out so juicy. When you cut your turkey and the juices flow out of it, that's when you know you nailed it. If juice doesn't come out of your turkey when you squeeze it, you killed it. You murdered it. You're a cruel, inhuman monster, and you destroyed that turkey. But when the juices come out, oh my god, you taste it, and it just tastes so good. And I realized they're ripping me off on that turkey too. See, this is the kind of thing. Yeah, turkey. This is the kind of thing that really pisses me off. This annoys the living hell out of me. So this is my favorite one. It's herb seasoned, boneless roast, 3 pounds. Damn. We have a high wind advisory today, and they're not kidding. Holy shit, is that wind blowing? Jesus. Um. So, oh, you can't see what I'm doing. I get these. Now you're thinking, okay, $4.57 a pound. That's not a horrible deal, right? I mean, it's not a great deal, but it's not a horrible deal until you realize there's like a half-pound pack of gravy inside this, and that's part of the weight. It should be $4.57 a pound for the turkey, not for the gravy, because paying $4.57 a pound for gravy is insane. Who would pay $4.57 a pound for gravy? But you are, because let's say you get 3 pounds. You're not getting 3 pounds of turkey. You're getting 2.5 pounds of turkey and a half a pound of gravy. That annoys the hell out of me. I hate that. And then this pisses me off. So, first of all, they dramatically raise the price, which really pisses me off, of course, because they're ripping you off when they do that. But this used to be like $6. Now it's $10, and it's even worse for the big ones. But let's look at a single can here. Let's get close to enough to see a single can. So here it says, 2 12.5 ounce cans, 354 grams. So you're thinking, okay, so how much are you paying per pound? Well, that's $3.83 a pound. But that's not actually true. You're paying more like $8 a pound, not $4 a pound. These cans are $8 a pound because they're counting the fucking water in the can. You don't get 12.5 ounces of chicken. You get 12.5 ounces of chicken and water, and there's only about 6.5 or 7 ounces of chicken in the can. The rest of it is water. I'm not even talking about squeezing the chicken, draining the water. That's not fair. You got to include the moisture that's inside the food because, that's part of the food, okay? But all the water that they used to pack the can, that didn't come from the chicken. They added that water. So they're charging you $8 a pound for water. You're paying $8 a pound for chicken and $8 a pound for water. That's bullshit. They should be required to put the weight of the actual meat. If you're buying chicken, it should be the weight of the chicken before the water is added. How does our system allow us to be scammed? That's fraud. That's literal fraud and deception. You go and ask 1,000 people who don't already know this, meaning you take 1,000 random Americans who aren't aware of this, and most aren't, and you ask them how much chicken is in this can. They're going to look at the can and say it's 12.5 ounces, and that's how they're going to judge how fair the price is that they're paying for it. They don't realize you're only getting 6.5, 7 ounces of chicken, and the other 6 ounces is fucking water. No, they do it for all of them. Why do you think albacore tuna costs so much more than chunk light tuna? Because there's no water. The chunk light tuna is full of water. So here's chunk light tuna. And chunk light. Solid white albacore. This is a 5-ounce can of chunk light tuna in water. This is a 5-ounce can of solid albacore tuna in water. Are you seriously trying to tell me that there's the same amount of water in this can as this can? It's not even close. Yeah, but see, if the water is naturally part of the food, then I'm okay with that. Like, I see people who they cook it and then they weigh it. You can't do that. You got to do pre-cooked weight because it's going to release moisture as you're cooking it. And that moisture is part of the food. If they took that moisture out first, your food would taste like shit. But that's not the case with something like this. Both of these cans are 5 ounces. This is a 5-ounce can of Albacore. This is a 5-ounce can of Chunk Light. Now, take this Chunk Light can, drain the water from it, and weigh what you have in the can. And now take this can and drain away the almost non-existent water in the can, because this is Chunk Albacore. So it almost entirely fills the can. So you're getting 5 ounces, you're getting maybe 4.5 ounces of tuna, or 4.8 ounces of tuna, and a quarter of an ounce of water. While this, it could damn near be 1/3, 2/3, or maybe even 50-50. I haven't actually weighed it, so don't quote me on that. But you're paying for water. This you're not. That's why this is $1.82. Because you're actually getting 5 ounces of tuna, and here you're only getting 3 ounces of tuna. You wonder why is the price difference so dramatic between Albacore and Chunk Light, when just the higher quality fish shouldn't result in that big a price difference. And once you open the cans, you immediately realize they're selling you water here with tuna in it. Here they're selling you tuna with a little bit of water. So when you adjust the price, it comes out much closer to what it should be, the difference for a quality difference in food, and not just a I would have to compare same brand. Here's Albacore. So this would be a better price comparison. So subtract 88 cents from this, and that's a more appropriate price difference, a 70-cent price difference. Because these are both giving you 5 ounces of tuna and water. But this 5 ounces of tuna and water, forget about the quality difference. This 5 ounces of tuna and water comes with more tuna. If you've ever opened a can of Albacore tuna, you know what I'm talking about. It's mostly tuna. It's big, giant chunk of tuna in there. While this is a tub of water with tuna in it. And that should not be legal. Even if they're allowed to include the water, which I don't have a problem with, they should not be allowed to reflect the water in the price and the weight. Meaning, not the price. Okay, the price you pay, whatever it is. Like, for example, this can of chicken would not suddenly become cheaper if they were required to put on this can 7 ounces. Let's say there were 7 ounces of chicken in this can. I think it's like 6.5. I think I weighed it. I don't know. Don't quote me on that. I could be wrong. But let's say there's 7 ounces of chicken in this can. I'm not saying they need to charge less. I'm not saying they need to change the price. What I'm saying is the label needs to say 7 ounces. They can include the weight of the water. They can have, 2 numbers here. They can have, 7 ounces, 12.5 ounces net or gross. So gross, 12.5 ounces, net 7 ounces. But it should be possible for the consumer to look at this and know how much chicken they're actually getting, and then be able to do the math. And the grocer should be required to use the meat weight when calculating this per pound number. Because if you calculated this per pound number correctly, I think it was actually 6.5 ounces of chicken. So 5.98 divided by 6.5 times 16. $14.72 a pound. You're paying anywhere between $14 and $15 a pound for canned chicken. That's fucking insane. That's nuts. There's no way that should be legal. And remember, my numbers could be off. Maybe there's 8 ounces of chicken in there. Maybe I'm remembering wrong. But the point is, there's a lot of water. The water is a substantial fraction of the total mass of that 12.5 ounces. You're getting nowhere near 12.5 ounces of chicken. And that should not be legal. Not the not giving you 12.5 ounces, but implying you're getting 12.5 ounces because they're counting the weight of the water in the measure. So I'm not saying they need to lower the price. I'm saying they need to put the correct weight of what you're actually buying on the package. Just like when you buy something, ham, water added, it says water added 20% by weight. So they're telling you that 20% of the mass is water added. Now, first of all, that should be illegal. If they're going to charge you a per price pound, if they're actually adding the water, they shouldn't be allowed to charge you the full meat price for the water. But as far as canned products, the can should indicate how much is actually in the can, not counting the water. I'm not buying water. I'm buying chicken. If I want to buy water, it's 97 cents a gallon. Okay? That's like 12 cents a pound, not $15 a pound. I mean, like, what the fuck? I mean, that's such. I mean, I didn't realize how big the difference was. I mean, if it was simply, if we were talking this 12.5 ounce can had a half an ounce of added water to it, I'd be fine with that. It's like, okay, it's part of the process. All right, you're not going to put the raw chicken inside the can. There's going to be some water in there. This is them intentionally saying, put less chicken in the can and replace it with water. That's what's happening here. Because they could make the can smaller and use less water, or they could put more chicken in the can and use less water. They chose to intentionally put less chicken in the can and replace it with water, because water costs them nothing. It's effectively a zero cost compared to the cost of everything else. That should not be legal. That should not be allowed under any conditions. There's no conditions under which that should be allowed. Now, if the water comes from the food, fine. That's normal. If you take a piece of fish and you weigh the fish, that doesn't matter. They're still going to charge $5.98 for 2 cans. The price isn't going to change. But your perception of the value of what you think you're buying will change. People will go, oh, wait a minute. It's $3 for 7 ounces of chicken and not $3 for 12.5 ounces of chicken? Well, maybe I don't want those cans now. And now market forces might force them to take less profit in order to sell the chicken, because now people... Okay, supply and demand and market forces are based on a perceived value for the product. They are lying about the perceived value of the product. That's like that's like you going to buy a Lamborghini, and then you find out it's actually a Volkswagen with a Lamborghini kit body, but he used a couple Lamborghini parts. So yeah, you're buying a Lamborghini, but it's not what you think it is. But you're paying a Lamborghini price. You're paying the $125,000 for a Lamborghini and not the $75,000 for a really nice kit conversion, because you think you're getting a Lamborghini. So it's not that they're charging too much, it's that they're lying to you about what you're getting. So you don't realize you're being charged too much because you think you're getting 12.5 ounces of chicken. Nobody, fucking no one, except people who know this, think you're getting 12.5 ounces of chicken and water. You think you're getting 12.5 ounces of chicken. This would be tantamount to them including the weight of the can in the marking on the can. Like it'd be like you finding out, oh, you only get 4 ounces of chicken because you got 8 ounces of water and 3 ounces of metal making up the can. Nobody would tolerate that, but they tolerate this. They should not be allowed to do it. It should not be the responsibility of citizens. It should not have to be the responsibility of citizens to educate themselves to realize they're lying to me. And now I have to go home, empty out my can, weigh the chicken. How much do I squeeze the chicken? Because they're adding water, which means the chicken has more water in it than it did off the bird. So, what is the density of chicken breast meat, of natural chicken breast meat? I'm supposed to figure that out to figure out what I'm actually paying? That's not right. If they add any water whatsoever, that water should not be allowed to be counted on the weight marked on the can. If they still want to charge $5.98 for 2 cans, that's fine. But that number should correctly indicate how much chicken was actually put in the can. And you can tell just how absolutely corrupt the entire system is because it's not. And that's such an obvious thing. That's a smack on the forehead. Well, duh, of course it's like that. No, it's not. What do you mean it's not like that? Of course it's like that. No, it's not. They're including the weight of the water they added. They're not including the weight of the water that came with the chicken. They're including the weight of the water they added to the chicken. It's like this is literally this is actual fraud. It's legalized fraud. This would be absolutely positively no different than me selling you an ounce of gold and not telling you it's 60% gold and 40% brass or 40% silver. There is absolutely no difference. My package says gold 1 ounce, but it's not gold 1 ounce. It's 0.6 ounces of gold and 0.4 ounces of silver. That's fraud. If I did that, you could sue me and I would lose. I would be charged with fraud. Yet that's exactly what they're doing here. They're saying 12.5 ounces of chicken because this says 12.5 ounces chunk chicken breast with rib meat. But they probably get away with it because the government probably says, well, you just have to put in water. I mean, what the fuck? I mean, yes, chicken releases a lot of water. It doesn't release 40% water. And that's just not how that works. So this number should reflect how much. Well, rib meat is a lesser quality meat. I actually like rib meat. I like dark meat. But beetle caps. Well, like for example, some things make sense. Some things aren't it's not a scam, and it's also not a big deal, but people think it is. Let's forget about the fact that cereal in general is a scam, because there's no way in hell a fucking 24-ounce box of cereal should cost $5. That's batshit insane. This should be $1. Even this is stupid. 30-ounce bag for $5.50. Even the off brands cost as much as the name brands now. That's about the same price when you factor in the weight difference. You say, well, wait a minute, this is $1 more. Yeah, but it's also got 6 ounces more food. So it's really not that different price. Yeah, look at the price. 18.3 cents an ounce versus 18.7 cents an ounce. No. Half filled doesn't matter because that's something people will educate themselves on. The very first time you open a bag of chips or you open a box of cereal, you're going to realize, and actually they usually are pretty full. They're usually about 85% full. For canned chicken, there's a lot more than 10% water in there. Or you talk about fresh. Because I know the rules are different for fresh versus canned and whatnot. But these cereals are just insidiously expensive. It's fucking made of wheat. They're made of the absolute cheapest ingredients on planet Earth, but they charge an exorbitant difference. Yeah, Coke would be different too. Because cooking is going to release more moisture. But I could tell you this, When I cook a chicken breast, it does not go down in weight by 40% after cooking. Nowhere close. It might lose 10% total. A pound of chicken might end up being 0.9 pounds after cooking it. Because chicken's a pretty lean meat. But it's not like my pound of chicken became half a pound. I mean, it's just incredible. And either which way, even if that's a part of the process, they should be required to reflect what you're actually paying for. When I buy 24 ounces of cereal and I dump out the cereal into a scale without the box and packaging, I get 24 ounces of cereal. I don't get 12 ounces of cereal. I've cooked chicken. It doesn't lose half its weight. I mean, of course it loses weight. You're losing moisture. The moisture's evaporating. You can see that. It's not losing half. It's just not. Plus, they boil the chicken, so it loses less moisture. I know you didn't. I'm just making the point that they're adding a lot of water, and even if, and that's fine. If they need to add water for their process, that's fine. I don't care about that. What I care about is that this number is not correct. You're not getting 5 ounces of tuna. You're not getting 12.5 ounces of chicken. So I just want the number. I'm not saying they have to change the price. I'm not saying they have to do anything except put the correct number on the can. When the difference is that big, when even if the difference is a natural, legitimate part of the process, the number on the can should reflect consumer perception. If the consumer thinks that number equals how much chicken is in the can, then that number should equal how much chicken is in the can. I'm not saying they have to charge less. Just change the number to reflect what people expect. When I get 24 ounces of cereal, I get 24 ounces of cereal. When I get 12.5 ounces of chicken, I don't get 12.5 ounces of chicken. Okay? You say, well, that's cooked weight. Well, you chose to include cooked chicken, so you have to include the weight of the chicken, not the water. That doesn't mean you got to charge less. It just means the label has to be honest. The label has to say what I'm actually going to get inside that can. They can include both numbers. They can say, 6.5 ounces of chicken and 5.5 ounces of water. Or they can have the two weights, gross and net. So gross would be 12.5 and net would be 6.5 or whatever it is. I'm guessing on that number. I could be totally wrong on that. I just remembered it not being very much chicken when I took the water out. But actually I could probably figure it out if I poured the water into a cylinder and got how many milliliters it is. It's pretty easy to convert milliliters to weight since we know the density of water. But yeah, these prices for cereal are just batshit insane. But cereal, a lot of people don't realize this. According to the government, according to the USDA. Wow, 40%. I was right. It's 40%. I was spot on. It was 40%. Wow. That was just an estimate on my part. I thought maybe I was off a little bit. Holy shit. 40% water. Wow. So what's that mean it costs? 12.5 times point. What the fuck was that? Something slammed shut. So I'm getting 7.5 ounces. So 5.98 divided by 7.5 times 16. You're paying $12.75 a pound. Exactly. Like I told you, the in water was their get out of jail card, and we're supposed to guess what that means. Well, it's It's in metal too. So are they allowed to say in metal and then count the weight of the can? You see how preposterous it gets? So that chicken is, oh, I'm sorry. Divide by two, because there's two cans. $6.40, $6.38 a pound. There's two cans in that price. I fucked that up. So you're paying $6.38 a pound for what normally costs you $2 a pound. So they're tripling their profit. But you don't lose 40%. Well, I don't want to do a recover. They're selling cooked chicken. That's not my fault. They choose to sell cooked chicken. They should still be required to disclose the weight of the chicken. Now, if they want to include an explanation, chicken loses 20% water during the cooking process. That water was part of the chicken naturally. They can include that. But the number on the can should reflect how much chicken is in the can, regardless of how the chicken got to that weight. You know, when I buy a pound of hamburger, I get a pound of hamburger. I understand that I'm going to lose some of that weight when the grease comes out. And I can choose to buy raw chicken, $2 a pound. On sale. That's all right, D-Wit. So, yeah. Well, right now it's $2.97 a pound. But I only buy it when it's $2 a pound. Anything on sale, $2.86 a pound. This would be more appropriate. Oh, wow. So I guess there is no possible way of getting seafood affordably, because the prices are out of this world. Wow. Grounded. Oh no, you got to call it grounded beef. Um, hey, eggs finally came back to something reasonable. 12.22 for 60 large eggs. That's less than $2.50 a dozen. That's almost back to normal. Normal is just under $2 a dozen around here. So that's almost back to normal. Yeah, because they want to add as much water as they can because water's cheap, chicken's expensive. The more water they add, they don't have to reduce the price. You're not paying less. Cool. Maybe I'll show you how to fly a rocket. Well, they're still pretty expensive for the dozens. Oh no, actually they came down. The dozen's $2.56. This was $4.86 yesterday. Yeah, $2.56, $2.82. These are extra large. So the price, maybe enough people started, because now you have to remember this price, the price of eggs. You should be afraid. You should be very afraid. And I'm poisonous and venomous. Don't forget that. So I bite you, you die. You bite me, you die. Either way, you die. Yeah, your car might be faster, but my rocket's faster than your car. I got into a half-hour rocketry discussion with a guy once because he I don't even remember how it started, but we got into a verbal argument in the parking lot, and he non-maliciously, like I could tell he wasn't really serious, but he threatened me, and I said I'll kick your fucking ass, And before I finished saying fucking ass, he says, your fat ass couldn't catch me if you tried. And I turned around, plopped a rocket on top of the car. And I was like, are you faster than that? And he's like, you fly rockets? And I was like, hell yeah, I fly rockets. He's like, I fly rockets too. We spent the next half hour talking about rockets. That was hilarious. I love that. That was a fun memory. But now something that people don't realize is that the increase in egg prices that came from Walmart. Now, I don't mean Walmart exclusively. What I mean is that came from the retailer. Egg prices did not go up. The egg farmers were still getting paid the same price for their eggs while we were paying $6 to $8 a dozen for eggs. The retailers raised the price of the eggs, not the farmers. They were getting fucked. And I guess now that they got caught, the prices are coming back down. And I guess enough people are bitching about it. Like, okay, the jig is up. We better lower these prices before the fucking, FTC comes after us or some shit. Because if enough people scream, then they have to act. When people weren't screaming, they just blamed it on inflation, even though there really is no inflation. When I say there is no inflation, I don't mean there is no inflation. I mean there's no real extra inflation. The inflation this year is not appreciably different than the inflation last year or the year before. What you're seeing is not inflation. What you're seeing is price gouging. Massive, across the world, across the scale, across the industries, price gouging. And they're blaming it on politics, inflation, and the war in Ukraine. They're using those three things as scapegoats to permit massive price gouging. And that massive price gouging is occurring because employees are demanding higher wages because they're tired of being literal slaves. And because the pandemic created a labor shortage, an actual labor shortage, there is not enough people to fill all the jobs. There are more jobs than there are people. Because of that, when there's an actual labor shortage that is large enough to affect industry, that's the only time in our feudalistic system where some power shifts to the employee, where the employee has some kind of a say, because now they can choose between the $12 an hour job and the $15 an hour job and the $19 an hour job. They actually have that choice now in some places. Remember, the national average wage at McDonald's is still $9 an hour. Most McDonald's employees are still making $7.25 an hour, or close enough to $7.25 that we're going to call it $7.25. I love how they say only 12% of the workforce earns minimum wage, which means you're not including everybody who makes 1 penny more than federal minimum wage, and you're not including anybody who makes less than the federal minimum wage. You're including this one single slice of the population. Most employers will pay you a couple of pennies over minimum wage just so that they don't have to say they pay minimum wage. You're still being paid minimum wage. If you're getting less than $24 an hour, you're being paid minimum wage. Minimum wage is $24 an hour. End of discussion. Minimum wage is $24 an hour. If you make less than $24 an hour, you're a minimum wage employee. But minimum wage is $7.25. Well, New Mexico says it's 12, and California says it's 15, and New York says it's 11, and stuff doesn't cost more now than it did in 1960. That's a failure of understanding of inflation. So, here, this is an oversimplification, but it will make sense. We're going off the rails now. We've been streaming for 3 hours and 30 minutes, so if you don't want to hear the off the rails stuff, we're pretty much done with the 3D printing, and now we're doing the After Dark special. So we're going to talk about other stuff. I'm fine doing that as long as I separate. As long as I gotta try not to mix it in. Like, wait until we're done this, and then we switch topics. Okay. Inflation is when currency loses value. So we have a currency. It's money. Exactly, we were. Ever since we switched to Turkey, we went off the rails. But I was about to end. We were just about done. So if you don't want to hear this, don't stay. You won't offend me. It's fine. Um, we're gonna keep it non-political though. We're gonna keep it to the science and the math and the facts. I have a politics channel. If we want to do that, we can do that. Mind of Nerys. That's all the politics, the ranting, and the raving. So, inflation is when the number gets larger, but that's not actually what inflation is. What inflation is when your root currency becomes worth less. Ostensibly, okay, money doesn't become worth less. Money always maintains an equivalent value. Now, this is not strictly true, but it's close enough to being true that we can use it as a parable example. It's 1955, and you want to buy a car. Well, here's what I want you to do. I want you to take the bills, the dollars, the currency that equals a car, and hold it in your hand. And then I want you to take a chunk of gold worth the same amount as that currency and hold it in your hand. And you're going to take that money and that currency and you're going to put it in a box. So you're going to stick that in a little geocache container. You're going to stick that in a time, what do you call that? A time thing. What do you call when you put a time thing underground and people dig it up later? Get the word for that. It's time something. Time capsule. That's it. Capsule. I couldn't remember the word capsule. So you take that time capsule and you put 1 car's worth of cash in there and you put 1 car's worth of gold in there and you seal it up. It's now 2023. You open up your time capsule and you have the same cash you put in there and you have the same gold you put in there. Now you're thinking, okay, well, you can't buy a car with that. You might only have $1,200 in cash in there, and you can't buy a car for $1,200. A car is about $15,000. Because you could buy, there's like 7 brand new cars you could buy for $15,000. So brand new cars, 15 grand. Here's the weird thing though. That piece of gold that you stuck in there in 1950, it'll still buy a car. That piece of gold is still worth what a new car is worth. So the car didn't change price, and the gold didn't change price. Well, okay, I guess the terminology becomes difficult because there's a lot of crossover. We're going to call price the number, and we're going to call what it's worth value. Okay? So the price of a car has changed, but the value of a car has not changed. A car is still $15,000. It was $15,000 back in 1950, but the price we attached to that $15,000 was $1,200. But the value is the same. So if the gold is still worth the same amount the car is worth, well, that means the gold hasn't changed in value. And the car hasn't changed in value because that piece of gold will still buy a brand new car. So what has changed? The value of the money has changed. So I'm going to use 1968 because that's peak wage year and that's numbers. I have numbers for it. In 1968, I am going to convert all of these numbers to $2,023. Well, first, let me explain conversion. You use loonies. You have Canadian dollars, okay? When you come to the United States, you can't use Canadian dollars. You have to convert that to US dollars. Let's pretend for a moment that it's a 2-to-1 conversion, Canadian to US, just to keep the numbers simple. We know it's not. It's like 80%, 20%. We're going to call it 2-to-1. So you have $20 Canadian, and you come into the US and they take your $20 Canadian and they give you $10 US. Let's assume no conversion fees. And they give you $10 US. Do you have less money? No. You have the exact same amount of money. You have the exact same amount of value. $10 US is worth $20 Canadian. $20 Canadian is worth $10 US. Barring price gouging and regional differences, a $10 item in the US is going to cost you $20 in Canada because 10 and 20 are the same value. Different currency, same value. When you have inflation, you have to treat each year's US dollar as if it's a foreign currency. So you'll see somebody post a picture of a gas station in 1952 when gas was 27.9 cents a gallon. They always get pissed off at me when I go, oh, wow, so gas prices haven't changed very much in 50 years. What do you mean? Well, that's $3.16 a gallon. I can go and get gas for $3.15 a gallon in Albuquerque. So it's almost the exact same price as it was then. It's 27.9 cents. No, it's 27.9 cents in 1952 dollars. Unless you have a DeLorean, a Mr. Fusion, and you hit that 88 miles an hour, you're not allowed to have 1952 dollars. You only have $2023. Which means just like you have to turn in your loonies and convert them to dollars, you have to turn in your 1952 numbers, 27.9 cents, and convert that to 2023 numbers, $3.16. How did I get that? There's an inflation calculator you can bring up. So you go to usinflationcalculator.com, and if we change this to 1952, and we put in here 0.28 cents, it's $3.16. So 28 cents 1952 foreign currency dollars is exactly the same value as $3.16 2023 dollars. So in 1968, minimum wage was almost $14 an hour because minimum wage was $1.60, which converts to $13.75. So a minimum wage worker got paid $13.75 an hour in 1960. Nobody in the country could be paid less legally than $13.75 an hour. Median adult white male. We don't need inflation. Inflation is a consequence of the devaluing of the currency. Think about it this way. Now, this is an oversimplification, and this assumes a real money, like a gold standard kind of thing, but the same thing applies here, but it's different. It's not quite the same, but this oversimplified example does explain it. Let's say I have $1, okay? And I have a dollar coin. This is two same things. I have $1. Now, this thing has two numbers attached to it. It has a price, which is $1, and it has a value, which in this case is the same, $1. What does value mean? Value means what can I buy with it? Let's say that this allows me to buy this geocache container. Okay? Now, we don't actually trade dollars. Okay? That would be like me handing you a piece of gold. Okay? And we used to do exactly that. The money used to be made of gold, silver, and whatnot, and you'd actually be trading real money. But when the economy starts getting bigger and bigger and bigger, the power's flickering, but my UPSs should hold out, I hope. It's getting feisty. The TV's not on a UPS. I'm surprised it stayed on. So, we used to actually trade in money. Okay, I would hand you a piece of gold or a piece of silver, 2 bits, stuff like that. It was actual money, real money. We don't use money anymore. We now use currency. Okay, currency is a piece of paper that represents this much money. So now you have a separation between the money or the money and the currency. So the value and the paper that represents the value. Well, this creates an interesting situation. If I only have money and I want more money, and this money is gold, well, the only way for me to get more gold is to go dig up more gold. I have to go get more gold. But when I have paper that represents money, I can just print more paper. I can print 2 pieces of paper, but I still only have 1 piece of gold. Now, if all of the gold represents all of the paper, and I have 1 piece of gold and 1 piece of paper, well, then 1 piece of gold equals 1 piece of paper. $1 has $1 buying power. But if I print a second dollar and I dig up a second piece of gold, well, the ratio stays the same. These 2 gold equal these 2 pieces of paper. So 1 paper, 1 gold. The value hasn't changed. But what if I print a second piece of paper and say, these 2 pieces of paper now represent all of the gold, and there's still only 1 piece of gold? Well, now each piece of paper is only worth 50 cents. Because both of these pieces of papers must equal this piece of gold. Okay? And if I print 2 more pieces of paper, so I have 3 pieces of paper, but I still only have 1 piece of gold, now each piece of paper is only worth 33 cents. So if I want to charge you 1 piece of gold for 1 geocache case, and you say, well, I don't have gold, I have money, I have currency, I have paper dollars. Okay, well, the ratio between gold and paper is 3-to-1, so I need 3 of those dollars. But yesterday it was only 2 of these dollars. Well, yesterday 2 of those pieces of paper was worth 1 of these gold. Today, 3 of those pieces of paper is worth 1 of these gold. You see what I mean? Well, no, actually, silver was the base currency, and then gold, and then other stuff. Some people sold salt. Some people use shells. The whole point of basing currency off of precious metal is that the precious metal is rare. It's difficult to copy. It's difficult for me to go get a bunch more of it. It's hard for me to do that. Even when you have governments digging up mass quantities of gold, the amount of gold relative to the amount of people is low. So its value is in its rarity. It's difficult to counterfeit. You can't just print more gold. You see what I mean? And so it has an intrinsic value. That's why if we were to go back to 100 years ago, you traded gold for goods. 100 years ago, you did that. This was not way back. This is one person's lifetime. Why do you think we have gold dollars from 1910? That's what it was worth back then. Now, we don't use gold today, but we still have value. And that value is a gold equivalent. It serves the same function as gold. We use what's called a fiat currency. Our dollars used to actually be based on gold. You can get a silver certificate and a gold certificate. That's $1 and $5 bills that were actually worth that amount of gold. You could actually go to the Federal Reserve, hand in your $1 silver certificate, and they would give you $1 of silver. Actual metal. We don't do that anymore. That was real currency that was actually based on value, based on something. That was real money. Now we use what's called a fiat currency. This is worth $1 because we say so. Now, there's nothing intrinsically wrong with that. There's nothing intrinsically wrong with fiat currencies. They're perfectly fine. When you have, we have 330 million people in this country. Could you imagine trying to divvy up gold? Could you imagine your boss trying to pay you in gold bars? It just wouldn't work. It's not practical. So there's nothing wrong with a fiat currency, and there's also nothing wrong with a fractional reserve banking system, which we have. That's a whole other discussion. These things aren't bad. They do not cause inflation. They don't do anything wrong. It's when they're abused that they do. So we don't use gold. We have this mythical thing called value. What is the value? Well, value is based on the world's trust in your currency. The people, what they perceive the value of your currency to be. If you start spending like crazy printing money, they're going to perceive your currency as being worth less. Now, the United States currency is actually even more different than that. United States currency is what we call a reserve currency. It's a currency the rest of the world uses as a metric to value their own currency. And it's also because they will buy U.S. Treasury bonds, U.S. dollars, or basically buying U.S. money because it's stable compared to relative to the rest of the world's money. Look how much the value of the Canadian dollar fluctuates up and down. Now look at how much the U.S. dollar fluctuates up and down. Because we are a powerful nation, we are a stable nation historically. Historically speaking, we're a very stable nation. And so what is worth $1 in the US continues to be worth $1 year on year, barring the base rate of inflation. The 3% or so. Now, when you go over decades, the difference is big, but when you go over year on year, the difference is not very big. Now, we have also attached the value of the US dollar to a resource that the world absolutely cannot live without: oil. So the dollar is very closely, in the past, the dollar has been very closely connected with the value of oil. One of the largest exporters of oil in the world is the United States, not the Middle East. The Middle East controls the rest of the world with OPEC, but the U.S. is one of the biggest exporters of oil in the world. So attaching us to oil was a smart move when the world revolved around oil. Now the problem is that's why we've had so many wars. Because war's good for money. You make lots of money when you have war because you get to build lots of war machines. But also, most of the countries that we've fucked around with in the past, we've done that because they've threatened to sell oil in something other than US dollars. The world currency for selling oil is US dollars. Everybody sells oil in dollars, which is why there's a connection between dollar and oil. Which is when oil's strong, the dollar's strong. Which is why we like to keep oil expensive while telling citizens we're trying to save them on the gas pump. When we're lying, we want to keep oil expensive because it keeps the dollar strong. One of the biggest reasons we're having a problem with China and Russia right now is because China and Russia are looking to work together to start selling oil in other than US dollars, which will begin to whittle away at the reserve nature of the US dollar being attached to oil, because now, the Chinese yuan could become a reserve currency. If they do that, and if they succeed at doing that, and it boosts the value of their currency, it's going to reduce the value of our currency. It's literally economic warfare. And that's why you see a lot of this shit throwing, this feces throwing going on between Russia, China, and the U.S. China and the U.S. are attached at the hip. We've integrated ourselves into each other economically, and we cannot separate each other. The people say bring manufacturing back to the U.S. Well, see, the thing is, we don't need to bring manufacturing back to the U.S. We need to bring jobs back to the U.S. But that's what no. That nice big glass that I drink out of, that's made in the USA, but it doesn't create any U.S. jobs because it's all automated. China actually only owns 15%, 20% of U.S. debt. It's not very much. The vast majority of U.S. debt is owned by U.S. citizens. But economically, from a GDP perspective, China is attached to the U.S. and U.S. is attached to China. And we have transferred so many jobs out of the country and so much of the wealth to the top 1% that the United States is beginning to collapse. It's not self-sustaining. We can't support ourselves anymore. That causes a problem for China because China is attached at our hip and they can't cut free. So China knows the US is going to fail. It's inevitable. It's going to happen. It might be a soft failure. It might be a hard failure. It might be a sideways shift. There's going to be a failure. This system has to collapse. Unless we accept going back to kings and queens and feudal lords, this system has to collapse. It's unsustainable. The infinite progression is not sustainable. It's an exponential curve, and we're approaching the infinity point. Once you approach the infinity point, you're done. Because unlike mathematics, which can go to infinity, people can't go to infinity. So we're going to get left behind. China knows this, and they know that when the US collapses, China will collapse with it. So even though I am not pro-China, I'm not sure what embedded growth obligation means. I mean, so much of China's GDP depends on the US GDP, and so much of the US GDP depends on China's GDP, that when one crashes, the other crashes with it. China knows this. And even though I'm not pro-China government, I think they're scumbags, but China is actually doing the right thing. China knows they're going to fall when we fall. Now, what is the one thing that survives a collapse? Why is it that every time we have a recession or a depression, the wealthy get wealthier and the poor get poorer? Why? Because real property survives collapses. If I own, 50 acres of land with farming on it, and society falls apart and collapses into depression, and then we reset, I've still got 50 acres of land with farm on it. So, and I've still got my car, and I've still got my 3D printers. Real property survives collapse. So China is doing exactly what they should be doing. They're taking the hundreds of billions of dollars a year that they extract out of the US economy, and they are funneling it into real property and resources. Oil, buildings, bridges, cities, infrastructure, power plants, deals with other countries for resources. They're spending all of their money in things that will survive the coming collapse. So that when this whole thing goes pa-boom, China will have something to rebuild from. What are we doing? We're enslaving the entire population, impoverishing the entire population, and saying, enjoy your TV and iPods! So, the problem is the United States does have one resources that is a very big threat to the rest of the world in the event of a collapse. We have the largest military on the entire fucking planet, and we will probably use it if we collapse. And that makes the rest of the world scared shitless. And that's why China is spying on us. That's why China is trying to build their industry. That's why they're trying to build their military, because they're afraid that we're going to turn our military on them and take what they're building up in the event of a collapse. That's my guess. That's a seat of the pants, relatively ignorant, uneducated guess, but I'm betting it's pretty close to reality. Yeah, you're our neighbors. Well, plus, Canada is basically the United States for all intents and purposes. Do you know there are more American citizens at a higher latitude than there are Canadians? Most people don't realize that Canada doesn't really exist in the bigger picture. Most of Canada is absolutely empty. Like 98% of the population lives on that little tiny sliver of Canada that penetrates into the US. Because it's too fucking cold everywhere else. That's why Alaska's empty. Because it's too goddamn cold. Canada has the same problem. It's too damn cold. So most of Canada actually lives right on the border, right at the bottom. That's not a cut on Canada. You just got the bad draw of the straw with all that cold. You can only take so much cold. But but that's now what happens is in a fiat currency, oh, as long as the world trusts your currency maintains value. Like I love when people say, exactly, Canada's gorgeous. Hey, let me tell you, Canada makes the United States look like a shit show. At least the little bits of Canada that I saw. 30 years ago, we went on a vacation where we drove the motorhome up to Niagara Falls, and then we rented a houseboat, and we traveled up the locks in Canada and back, and then drove home with the motorhome again. One of the best vacations I ever had. It was also one of the most humbling vacations I ever had. Because if you see the Canadian side of Niagara Falls and you see the American side of Niagara Falls and you realize the American side looks like the slums and the Canadian side looks pristine like it's out of a TV show, and you go, man, we are a sad excuse for a country. And that wasn't just Niagara Falls. Every town we went to up those locks in Canada, beautiful towns, well kept, not dirty. There's very little in the way of slums and stuff like that. I don't know the reason for that. I don't know if you're nasty to the slum people. Like I know Canadian government's been turning nasty against your natives. But I don't know all the details of Canadian life and family and stuff like that. All I know is that it was a lot prettier and a lot cleaner than most places here. it was humbling to realize it'd be amazing if America looked this pretty. So, you get my deep respect and congratulations for that. You guys, you keep your shit in order. Well, that's where they start. The slums start in the big cities. Small towns tend to be self-regulating. The number of people the town can support live there. The cities have resources that are close proximity, so poverty is going to propagate from cities. That makes a lot of sense. And even in the rural areas, even the impoverished people are usually a little bit better off than the impoverished people in cities. It's a balance. It's a weird. It's beyond the scope of what I understand and my knowledge and whatnot. But yeah, China is spending their money on things that will survive the collapse: infrastructure and resources. We're spending our money making the rich richer. And the military. You notice how the Republicans refused to approve any law last year until the military spending bill came up, and then sure, no problem, $9 trillion. But it was only $800 million times 10 years. $9 trillion. We spend more on our military than the next 26 most powerful countries combined. And 25 of those 26 countries are allies. Why do we have such a strong military? To maintain the value of the dollar, and because all of our industrial, military, educational corporations want that money, and they control the politics. Eventually, it's going to collapse. And I have a feeling I'm going to be alive when it happens, and that scares the hell out of me, because I was kind of hoping I'd be dead before that happens, because that's not going to be fun to live through. Not fun for Americans. Yeah. Do you know the only thing that has not increased at the rate of inflation? This is going to surprise you. Pretty much everything we have costs about the same as it was 55 years ago, 1968. A house costs about the same then as it does now, not counting the crazy inflated prices of houses near cities. But if you go buy a house outside of a city, the price of a house is not that much different than it was 55 years ago. The price of a car is actually cheaper now than it was 55 years ago. It's about $2,000 cheaper. There's a few outliers: education and healthcare. Those are out of control. Housing near major cities, out of control. But most everything else that you buy on a day-to-day basis, most of the normal equivalent crap that you buy on a day-to-day basis, if you found an equivalent from 1955, it costs about the same or less now than it did then. There's one exception. Food. I know where you think I'm going with this. You're wrong. Food is substantially cheaper today than it was 55 years ago. 55, 60 years ago, a pound of ground beef was $10 a pound. A gallon of milk was over $9 a gallon. A pound of coffee was over $5 a pound. Go look up the price of those three things today. A gallon of milk is $2.50. A pound of ground beef is $2.99 a pound, or maybe $3.99 a pound if you pay a bad price. All right, a pound of coffee you can get for less than $1 a pound, or $2 a pound. So food is substantially cheaper now than it was 50 or 60 years ago. There's a few exceptions. Bread and eggs are almost exactly the same price as they were 60 years ago. When you adjust the numbers for inflation, the price of bread and eggs has remained effectively unchanged in 60 years. But almost everything else, all the major stuff you buy, milk and coffee and ground beef and stuff like that, is substantially, not just a little bit, but substantially cheaper today than it was 60 years ago. So why does buying food hurt so much? Why does it feel like food is so expensive? Because we've been artificially deflating the price of food. We learned this from past dictators. We learned this from Adolf Hitler. We learned this from the Third Reich in Germany. People do not revolt until they're starving. It's the way nature works. You can't think of a country as individual people. That's not how it works. We're a group creature. We're almost like an amoeba when you look at us as a country. We work as a group think hive kind of thing. We do not act as individuals. When you look close to us, food's not insane near you. Food is not insane near you. Food is cheaper where you are now than it was 60 years ago. Not just a little bit cheaper. We're talking food is now 2 to 3 times cheaper than it was 60 years ago. So wait a minute. Food is insane. You're not wrong, but you're wrong. So what has changed? You're being paid less. That's what's changed. In 1968, minimum wage was $1.60, which was $13.75 an hour. Today, minimum wage averages about $6. Because you got people, anybody who gets tips gets paid less than minimum wage in half the states in the country. It's called tip credit. It's basically theft. It's outright theft. Median per capita income. Now, this is a tricky one because there's a lot of things that influence this. I am using your average, typical white adult male who decides to work 40 hours a week, because that's important for 1968, because misogyny and racism were out of control in this country in those decades. A black person could expect to earn 25 to 50% of what a white person would earn, and a woman could expect to earn 50 to 75% of what a man would earn. The disparity was that big. It was huge. The misogyny and racism were absolutely rampant, and that has nothing to do with currency value and wages. So we have to exclude those numbers to get a valid entry. So we have to look at the only group of people who weren't being prejudiced. All right, 45 cents in 1968, 0.45, $3.87. Oop, where is it at? So $3.87. Now, the paper that I usually see is from further back, because the further back you go, the more dramatic this becomes. Let's see. Old food prices. I want to say 1951. There was a there it is. Nope, that's Pizza Hut. There was there's a common thing people would post. It was about a particular year. I want to say 1951. Actually, I should be able to look it up. Because 1968 is too close for food. We had already begun manipulating the price of food to avoid, the Nazi problem, to avoid revolt. We realized that we had to keep the population fed in order to prevent a revolution. And so we began artificially deflating the price of food. Where is it at? Here it is. $19.59. Okay. Come on. So here we go. In 1959, let's see, vitamin D milk was $1.01 per gallon. Okay. So if we take $1.01 from 1959, that's $10.38 a gallon for milk in 1959. So paying $1.01 in 1959 for a gallon of milk is the same as paying $10.38 for a gallon of milk today. I think I don't even have to do this math. I think I have it on here. Yeah. You're going to go away. I'm never going to click got it. I refuse under principle to ever click that button. I'll just keep refreshing the page if I have to do that for the rest of my life. I will never click that button. Because I told a criminal scammer to lick my balls. You ever see those posts? You see it here, yo. I can show you one. I think I still have one of them saved. Nope, that's not it. I thought I saved one. Maybe I deleted it. Nope, that's not it. Oh, I thought I kept it. You see it all the time where oh, here's the numbers. I gotta refresh it again. I gotta refresh it 3 times to make it go away. I refuse to click it. I won't do it. They can keep putting that message up for the rest of my life for all I care. I will never click that button. You see these posts, asking you to contact them on WhatsApp, or you've won a prize, or you're the winner today, I have something for you. And they spoof the avatar and the name of the host of the channel because it's a very popular video getting millions of views. So they use some ASCII trick to make their name look like you are, like if you watch a Meet Kevin video, their name will say Meet Kevin, even though they're not. They're somebody else. And they'll use the same avatar that Meet Kevin uses. So you think you're talking to the channel host. And he's saying, hey, you've won today's prize. Contact me on WhatsApp. And they're trying to scam you out of money by getting you to send them crypto or something like that, or get a donation from them or something like that. And they're just scammers. Okay. So whenever I see one of them impersonating a host of a channel that I watch, I'll tell them to lick my balls. I'll reply, lick my balls. And one of those scammers, one of those criminals, reported me for harassment and bullying. And YouTube accepted it. Talk about your system being completely fucked up. Really? I tell a criminal crook, a scammer trying to steal money from people to lick my balls. I even kept the PG-13. I could have said suck my dick, but I decided to keep it PG-13. I said lick my balls. And that got reported for harassment and bullying. I will die before I click got it to that message. I'll die first. So, granulated sugar was 89 cents for 10 pounds. Ooh, you can't see this. Which in 2022 dollars is $9 for 10 pounds of sugar. Which is, and the actual price where you can buy that sugar, no, I haven't fought on stream yet, is $5.30. And these other ones are the same. So vitamin D milk, $1.01 converts to $10.30. But today milk is actually like $2.50. Ground coffee, 95 cents a pound, which today would be $9.69 a pound, but coffee's actually like $4 a pound. Bacon, 63 cents a pound, which is $6.43. That's actually pretty close to what it is today. It's about $6 a pound. But that's these price gouge prices. Last year, it was like $4 a pound. Eggs is about the same. Eggs, 29 cents, $2.96, and that's about what a dozen eggs cost today, about $2.50. Ground hamburger, crazy, 58 cents a pound, which is equal to $5.92 a pound, and you can get ground beef on sale for $1.99 a pound. Fresh bread, 20 cents a loaf, which equivalent to $2 a loaf. You can actually get bread for less than $1 a loaf, but if you get a slightly better quality loaf of bread, like this, a fresh loaf of bread, it's about $2. So bread and eggs are about the same as they were in 1951. That's 70 years ago. Almost 75 years ago. But everything else same. Now, a house, $12,400. That would inflate to $126,480. Today, a house is about $140,000 to $160,000. Remember, outside of these major cities where the prices are going crazy. If you look up at a house in the middle of rural New Mexico or the middle of Idaho or the middle of Georgia or the middle of Alabama, it's going to be closer to this $140,000 to $160,000 price. Now, the reason for this increase between 126 and 160 is because the houses are almost double the size. Houses today average 2,400 square foot. Back then, houses averaged 1,400 square foot. Well, that one gets even worse. Average income, $5,016. That would translate to $51,000. At the time, our average income in 2022, $35,000. So you can see here, this is where the problem is. A car, $22,950. Now it's $20,000. It's actually almost $3,000 cheaper. A movie ticket, $10.20 75 years ago. Today it's $10. Gasoline, $2.55 a gallon. Then it was $3.25. Okay. Postage stamp, 41 cents. Today it's 60 cents. All right. And these can be explained. This postage stamp issue is because the federal government is trying to destroy the postal service at the behest of FedEx and UPS. We don't like the mail service because the mail service actually works. So we don't like it. How dare them show government can actually work? Do you know how much of your tax dollars go to the mail service? Zero. Zero tax dollars goes to the U.S. Postal Service. Not a penny. Not 1 cent of your taxes goes to the United States Postal Service. They are 100% self-funded. Most people don't know that. The reason the Postal Service is in trouble is because the Postal Service has been mandated to pre-fund the next 75 years of healthcare and retirement benefits in advance, and they only have 10 years to do it. They're basically trying to rob the Postal Service. No other corporation or government entity anywhere on planet Earth is required to fund 75 years into the future. No other corporation or government entity on Earth is required to do that. only the USPS. They are being required to pre-fund health care and retirement for employees who aren't even born yet. That's why your postage costs more. Because they're trying to destroy the Postal Service. There's only 3 government entities I trust, and they're the only 3 entities that actually work. And that's the U.S. Postal Service, the Census Bureau, and NASA. Everybody else can go fuck themselves. Yeah, they receive their postage, their shipping. That's postage. They're completely self-funded with their postage. They not one penny of tax money goes to USPS. They are net positive. But if you look at these prices, they're all about what they should be, except for housing in certain areas, and education, and income. In 1959, you could expect to make $51,000 a year. Today, you can expect to make $35,000 a year. Well, now it's $36,893. It's almost $37,000. Inflation over the last year. This was done almost a year ago. So stuff is not more expensive. You're being paid less. One of the first things they did was deprive us of education. And that was actually thanks to Ronald Reagan. And when he was governor of California, he went to Berkeley and told them to start charging for tuition. He convinced them to start charging for tuition. Now, all college wasn't free in the United States in the past, but it was common. It was commonplace for university education to be free in the United States of America. In the past, you did not have to pay for a college education. Some schools charged, like Harvard, right? Some schools charged, but most schools were nonprofits and did not charge, not even most, but it was commonly available to find a school that did not charge for education. Now, it's virtually impossible to find a school that doesn't charge for education. And that is to restrict education to the people we don't want being educated. Black people, who we made poor. And so we have collateral damage, and that includes white people now too. But we're just collateral damage. And then don't even get me started on student loans. That's just insane. Education should be free. There should absolutely never be a charge for education, because education is 100% of the time a net positive for the country. There is no downside to the country to having an educated population. It should be free across the board. Anything you want, free. Because having an educated population will always, 100% of the time, net the country more in increased GDP than it will ever cost them to pay for education. It will never be negative unless it's rigged. Of course, you can rig it like we do now, over exorbitant rates and stuff like that. But a properly done education system shall never be a negative for a country. It is always a positive. You will always benefit the country by having a educated population. Well, you guys also have a much smaller and more expensive postal system. I mean, we have a postal system that, covers 330 million people. The fact that I can send a letter, that I can take, something the size of a letter and send it anywhere in the country in 2 days for 60 cents is mind-blowing. That's just incredible. And no, it'll get there, because lost mail is actually pretty rare. So it's pretty impressive. And they're being squeezed. They're squeezing the postal service because they don't like it. Now, in 1968, the average white adult male working 40 hours a week could expect to make $7,700 a year. If you take $7,700 a year from 1968, Exactly. And moose are no joke. They'll fuck you up. That means we can effectively say that median per capita income in the United States in 1968 was $66,000. If you look up median household income, it's about $68,000. That tells you something. That tells you something people don't realize. The vast majority of households in 1968 were single income earner households. One person worked. One full-time 40-hour week 9 to 5 job, and that paid for the entire family. And that's the way it should be. Don't take my word for it. US median. Are we on the right window? Am I showing you the window? Yeah. US median per capita income. Come on. You notice the difference between these two numbers? Everybody quotes this number, but this is the wrong number. This number is fictional. This number is a lie because this is the real number. Per capita income in the past 12 months, $37,683. That's the actual median per capita income in the United States. And that's right from the census. So wait a minute, what's this? This is just a hair over double this. So what's that tell you? That means 2 or more of the members of this household are working. And that's how they come up with that. You see, we didn't separate median per capita income and median household income in 1968. We just called it median household income because 99.9% of all households were one earner households. Dad went to work, mom stayed home with the kids. The nuclear family. That's how it worked. Today, that's not how it works. I'm willing to bet you that if you were to divide this number into this number, that it equals, let's find out. 69021 divided by 37638. 1.83. .6 persons per house. So more of this 2.6 is working today. That's the difference. The reason food feels like it costs so much, the reason the stuff around you feels like it costs so much is because you're not looking at the value, you're looking at the numerical number, and you're failing to realize that this is what has changed. In 1968, if you wanted to work full time, you could expect to earn $66,000 a year. Today, if you work full time, you can expect to earn $37,638. They have cut our income almost in half in the last 55 years. And that's why the food that is 1/3 the price of what it was 75 years ago feels like it's more expensive. Because we've been artificially deflating the price of food in order to prevent a revolt, to keep the people satisfied and happy. Because we have to eat. If you don't eat, you die. And so we base the value of our money on the house, car, and food it can buy. Houses have not gotten more expensive. Cars have not gotten more expensive. They've gotten cheaper. And food has gotten substantially cheaper. But remember, you equate the value of those things relative to how much money you make. And you don't realize you're being paid so much less because you think $7,700. And you forget about the difference between the number and the value. $1, 1 ounce of gold. $2, 1 ounce of gold. So instead of $1 being worth an ounce of gold, now $1 is worth half an ounce of gold. Now $1 is worth a third of an ounce of gold. That's inflation. And you have to convert. When you convert the buying power of their $7,700 into 2023, median per capita income was somewhere around $66,000. That's household income, but remember, it was a single earner household. So household income is per capita income. Today, it's $37,638. So you're making $30,000 a year less. You're making almost half what you made 55 years ago in buying power. That's why $10 a gallon for milk didn't feel like it back in 1959. And that's why $6 a dozen eggs feels horrendous today, because you're being paid less. Until people realize that, and they do everything they can to hide this, that's why they use median household income, even though median household income no longer applies. Median household income does not mean the same thing as it did back then. If our income stayed the same, median per capita income would be $66,000 and median household income would be like $140,000. But it's not, because they're reducing what we get paid while increasing the price of everything. Here, to put this in perspective, let's see. Oh, here's one. KFC 1972. Let me see if I can find this for you. I'm pretty sure. Wait a minute. Somebody was posting a picture of it. I don't think it was this one. There's a particular one that that somebody kept posting to Facebook. Maybe it was that one. Let's see. No, this isn't it. I thought it was 1972. Because they had the 10-piece meal. Oh, is this it? Nope. That's something different. Yeah, this is something different. It's really telling, and people hate me when I comment on it because they're trying to insinuate that prices are out of control and they don't like it when I correct them. Do I have a video of that maybe? Did I maybe post a video? I think I only did a yeah, I didn't do a video of that. Oh, wait a minute. I bet you I have it on my Facebook. Profile. Oh, but I don't know if I posted it as my own post or if I just replied to someone else's post. Okay, so I didn't post it here. So it's not part of that. So I just replied to somebody. Shit. Is there any way I can search? Is there no way to search my own post history? Like, is there no way to do that? What about, let's do a search for KFC, see if something pops up. Photos. Let's see here. It's got to be here. It's a really good one. It really drives the message home. But because they don't do the math, they don't realize that they're not delivering the message they think they are. Damn it. KFC prices Facebook. Damn it. I hate when I can't find it. I got to organize my shit better. I have the image somewhere on 88 degrees in February. Holy crap. It's pretty chilly today. Wow. 88 degrees. Holy crap. I'm pretty sure it was 1972. Wait a minute. How about this? KFC and Nerisse. I only wish. One. It's just not here. Damn it. Sometimes I swear they make stuff like this go away. Like they have a way of making it go away. That's the conspiracy theorist in me. But I'm almost. I thought it was 1972. Oh, here we go. Here it is. Got it. So, KFC, feed a family of four, $3.94. That's 10 pieces of chicken, two sides, because remember, one of these is a gravy, and six biscuits. So remember that. 10 chicken, two sides, six biscuits. First, how much is that today? So 1972, $3.94. That is $28.20. Okay? So here we have, where is it at? Right here. So here we have KFC, 10 pieces of chicken, two sides, six biscuits. Yeah, we're not looking for that. And six rolls. So you get two sides. It looks like three sides, but it's two sides and gravy. And when you buy mashed potatoes today, you get gravy with it. A side of gravy with it. And six biscuits. Now, I want to show you what it costs today. This is going to blow your mind. People just don't realize this. That food is cheaper today. menu. Let's see, family meals. So the closest family meal you're going to find is a 12-piece. So this 12-piece family, select store for price. Let's just do pickup. 87015. And yes, there is. I know there's a KFC in Moriarty. Oh, for Christ's sake, come on. Oh, it's much worse than that, Ben. And people have to see it to believe it. All right, 87035. I'm looking at the fucking KFC right there. Maybe they don't use the app. That's probably what it is. So we'll just pick one in Albuquerque. Okay. Why do they make this so difficult? It's right here. Why aren't you showing me the store? Why are you making me do it again? Fine. If you place a fake order, it's your problem. There we go. So, this KFC meal is $34 today. You're saying, wait, yeah, see, it's more. It's more. Well, first of all, it's not very much more. But the reality is, it's actually cheaper. Yes, $34 is cheaper because this comes with 12 pieces of chicken, not 10, and this comes with 3 large sides, not 2. When you add the value of the third large size and the 2 extra pieces of chicken, this is actually cheaper than KFC was in 1972 because people don't understand. You have to convert this. You have to think of this as Canadian loonies or Mexican pesos. You have to think of this as a foreign currency and you have to convert it to today's currency, and then you have to compare that converted number to the price today. Not only is it cheaper, you get more food. So back then you paid $28.20 for 10 pieces of chicken, 2 sides, and 6 biscuits. Today, you get 12 pieces of chicken, 3 sides, and 6 biscuits. And for a time, you got a half a gallon of soda, too. A month ago, you got a half a gallon of soda with it as well. So the prices have not gone up. Well, okay, the prices have gone up, but the value hasn't. The issue is $28 today equals $4 then. They're the same dollars. They're the same value, the same buying power. You had to work the same number of hours. You had to expend the same amount of labor and value. And people have difficulty comprehending this. I had a guy that said, well, in the 80s, our family made $40,000 a year between my mom and dad. And I'm like, dude, 1980. Whoop. That's $145,000 today. You were rich. Less than 7% of the population makes $145,000. But they don't comprehend. They're comparing 40,000 then to 40,000 today. Today, 40,000 should be minimum wage. 40,000 is what minimum wage should be. What is the number? 24 times 2,000. $48,000. Minimum wage should be almost $50,000 today. That's not minimum wage being crazy high. That's just keeping up with inflation. That's it. You'd be getting paid no more than you were paid. And in fact, this would still be what was it then? Let's see. 13.75 times 2,000. Minimum wage used to be $27,000 in 1968. That was minimum wage. But that was before food prices went back up, housing prices went up, taxes went up, education went up, healthcare went up. That's a big one you don't see mentioned. Healthcare. It used to be you would just go to the doctor and you would pay the doctor because the prices were reasonable. Health insurance? What's that? And what does that equal? 49 CAD to that's $36. So they're ripping you off for $3 or $2. They're charging you a $2 Canada penalty because that's 36 US and it should be 34 US. That's what you call the Canada tax. Now, is that with tax or without tax? But there it is. I mean, you can't argue with that. 394 converts to $28. And today it's $34, but you get 2 more pieces of chicken and an extra large side. Okay. Yeah, that's what we would call sales tax or GST or something like that. Here they call it something else. GERT, GRT or something like that. But basically it's sales tax. And here in New Mexico it's 8.1%. Whew, sales tax hurts here. And in Pennsylvania it was 6%. And there's the other thing that people don't realize is they don't realize how much we pay in taxes today. The average minimum wage worker, gross receipts tax, that's right, gross receipts tax. Same, it's sales tax. They're talking about this fair tax. They say it's 23%. No, it's actually 30%. Oh wow. So oh wow, it's snowing or raining or both. It's doing something. Um, the average minimum wage worker pays 40% of everything they make in taxes. And all the time, especially Fox News viewers, you'll see people saying, well, oh no, people on minimum wage, poor people don't pay any tax. They get it all back. No, they don't. They don't get any of it back. You see, when they say that, what they're talking about is base federal income tax. FIT, F-I-T, federal income tax. So base FIT. Yes, a poor person will get 100% of their base FIT back. The problem is base FIT is the smallest of the taxes we pay. We shouldn't. Not here in New Mexico. We have high winds today, but after that, nothing. I know the rest of the country's going to get slaughtered. At least I hope we don't get hit hard. I'm tired of the cold. We are looking at 44 degrees today, partly cloudy, windy. And then 48 tomorrow, mostly sunny. 59 Saturday, AM clouds, PM sun. So I'm looking forward to Saturday. That's when I want to try to do the water tank. 49 Sunday, 48 with some showers and wind. So we're looking pretty clean for the next week. Nothing below 40. The coldest day will be this one. And we might have some AM snow showers, 33%. Yeah, it's going to pass above us. The warm high pressure from the south is pushing the cold from the north, and it's keeping it above us just barely. So we're lucky. I'm in a lucky spot for that kind of thing. But yeah, mostly 50s. So I'm hoping for warmer because I got no heater. I need warm. I can't afford to turn on any more heaters. I have a fueled heater that I can run for 15 days, but I'm trying to save that because if I can't get this system fixed, I have no heat next year. So, well, Texas is west of us, so it's not from them. It's coming from the Pacific Ocean. We're here. Texas is over here. So you guys are over here. This warm system is coming from over here, from Pacific Ocean, Mexico, California, Nevada. Now, the bulk of it's going to sit on top of Texas, so Texas should be nice and warm. But north of Texas is going to get, there's a transition zone there where they're going to get slaughtered. Oh, it's going to be nasty, depending on how the weather goes. You can't reach high enough. Aren't you outside? Aren't you in Vancouver or something like that? Where's maps? It's close Tinkercad. It takes a lot of resources. Oh, here's maps. Go away. Yeah, I wonder why that KFC won't show Calgary, Alberta. Here we go. Oh, you actually live in the cold area. So we now have the targeting coordinates to program into the warhead. All right, I got a present coming for you. That'll warm things up a little bit for about half a second, and then you'll have nothing. Oh, yeah, most of Canada actually lives in the United States, meaning it projects into the United States. Most of Canada lives here. This area here and this area here. Most people don't realize that all of this is Canada. Most of Canada actually lives completely below North Dakota, Montana, Washington. Those entire states are a higher latitude than like 70% of the Canadian population. But most of Canada lives here, in this section here, this part here. Then it gets much, much thinner as you move up here. And then there's basically nothing up here. Just because it's so damn inhospitable. It's just like, eh. Like, how many cities do you see here? Like, what, 5? In Alaska? You got these little villages and stuff, but very little up here in Alaska. It's not uncommon for people in Alaska to own seaplanes because there's no roads. You want to get from here to there, you got to fly. So it's pretty barren. Here's a trick question for you. How many countries border the U.S.? How many countries border the U.S.? Yeah, I wouldn't want to live in Canada. Too cold. Although parts of Canada are about equal to where I lived in PA, or pretty close. Only a couple hours away. Most people are going to say 2 countries border the U.S., Canada and Mexico. Well, that's not actually true. It's actually 3. Because we also share a border with Russia. Most people don't realize that. Sometimes it's covered in water, sometimes it's not. But we also share a border with Russia because of Alaska. Is it that one or is it this one? One of these is split right down the middle. I think it's this. I think it's this right here. If I remember right, this is US, this is Russia. Something like that. But technically, you could argue 3 countries border the US. Yeah, the lowest part of Canada's down here below Toronto, and I live right here outside Philadelphia. So only like a 3 hour vertical difference. Toronto might be nice, but still cold. I don't. I'm actually, if I ever have enough money to move again, I'm actually thinking about um moving either out here to Rio Rancho or down here to Berlin, Boss Farms area. I don't want to go Bernalillo because then you have to get your cars inspected. But I'm actually thinking about if I ever have the opportunity. I might not ever have the opportunity, but I'm actually thinking about here or here because it's on average 10 degrees warmer in Albuquerque than it is here because the difference from here to here is about 1,800 feet in elevation. What most people don't realize is that all of New Mexico is high altitude. The lowest point in New Mexico is 3,000 feet above sea level. There's no place in New Mexico lower than 3,000 feet. I think it's like 2,925 feet or something like that. So almost all of New Mexico is high elevation. So our mountains don't look as majestic and amazing because we're in them. Oh, yes, absolutely. But most of that savings comes from, yeah, as long as you stay out of the city portion of it. Where's Berlin? Here's Berlin. Yeah, as long as you stick to the outskirts and not this central part here, crime is pretty low. Crime can get pretty bad in the central part here, but as long as you live like out here or out here, something like that, Boss Farms, for example. The only thing I don't like is Berlin's a little bit far. I'd rather do Los Lunas or Boss Farms because by living here or here, my car has the capability of reaching this entire city, even in the wintertime. The problem with here is that I have to have enough power for the 1,800-foot elevation change back up into Edgewood. So that elevation change really hampers how far I could reach into the city. Before my battery started failing, in the summertime I could reach all the way out to 45 here. So Bosky Farms. Okay. I didn't know that. I could reach all the way out to 45, so I could reach almost the entirety of Albuquerque. But well, maybe not all the way to 25, but definitely out to 25. I could definitely reach all of this, from whatever this road is, east. In the wintertime, I'm limited to about here. So this area here I can reach without having to recharge. Now, with the battery being bad, I probably can't even make it here. Because the battery will probably go into error shutdown when I give it enough throttle to climb back up this hill. Yeah. I even have trouble getting from Edgewood to Moriarty now. I went to Moriarty to go to Taco Bell and Arby's. Came back, and the climb up, because this is a couple hundred feet lower than here, was enough to trigger some of the safeties on the battery. And I thought I wasn't going to make it back to the house. And what's amazing is as I'm coasting down my street and pulling into my driveway, I actually watched the battery percentage go from, 4%, and then it goes 8, 12, 16, 19%. Like, what the fuck? How do you get 15% back? That's because the cells that were undervolting recovered. And so it recalculated the amount of power that was available. Yeah, it sucks. I don't know if I can get it fixed. I can't afford it. It's an $8,000 battery swap. It should be under warranty, but Nissan refuses to warranty it. They claim their computer says there's nothing wrong, even though they know there's something wrong. But they claim to initiate a warranty replacement, the computer has to say it. And the computer is not programmed to indicate this kind of a failure because it's not it's a capacity drop, but it's okay. It's a capacity drop, but the battery voltage is tricking the computer into thinking there is no capacity drop because the battery voltage on the bad cells looks normal until you place the cell under load. Then the voltage drops. But when their computer scans the car, it scans it at resting voltage. And so those cells look like they're okay. They don't actually stress the cells to determine if the cells are good or bad. They strictly look at their resting voltage to determine overall pack capacity. And that works when the cells are working properly. No, it's not a balance issue. Those cells are defective. They're bad. They don't work properly. When you place the cells under load, they fail. I did. I actually have video of the car almost killing me on the highway. And even the technician said, holy shit. But they will not warranty the battery until the computer says so. Now, legally, they have to warranty the battery. But if they choose not to warranty it, my only recourse is a lawyer, which probably would force them to warranty it. But I can't afford to pay the lawyer. I don't got thousands of dollars to pay a lawyer. Even if I would get that back, winning the lawsuit, the lawyer's going to want his money up front. I don't got it. So I have to look into small claims court and see what the limits are in New Mexico and to see if Mexico actually has a small claims court. Not all states have real small claims courts. Like Pennsylvania doesn't actually have a small claims court. They have something they call small claims, but that only works. Well, it's not a guaranteed win, so it probably wouldn't be pro bono. That's my next thing is to call the Attorney General's office. To make noise. Basically, I got to make some noise, and hopefully I can convince Nissan USA to warranty the battery. They tried to tell me... Hello? Nobody was there? They tried to tell me they see indications of rodent damage and that wouldn't be covered under warranty. I said, okay, good. Let's replace the battery. Hand me a bill for $8,000. And the guy looked at me like, what? I was like, just make sure you put on the bill rodent damage. He's like, oh, we can't do that. I was like, what do you mean you can't do that? You just told me you couldn't warranty it because you see potential signs of rodent damage. So let's replace the battery. I'll come back with a check for the $8,000. You just give me a bill that says rodent damage. And he's like, what do you mean? I was like, my car insurance covers rodent damage. I hand State Farm a bill for $8,000 for the battery for rodent damage and they'll cover it. Oh, no, we can't do that. I was like, oh, so you're telling me there is no rodent damage, that you're full of shit. And as soon as I go to the insurance company, they're going to want proof. And when you can't provide the proof, you just committed fraud. He thought he had a get out of jail card. Just claim we see rodent damage. How are you going to prove we don't see rodent damage? Well, easy. I'm going to claim it on my insurance, and then they're going to sue you for fraud because you said rodent damage and there wasn't. Because you don't want a warranty because you don't want to pay for it. It's like 5 hours. Basically, I have an app I run on the phone called Leaf Spy, and it tracks the individual pack. The battery is made up of 92 packs. There's 92 cells making up the pack. And about 4 or 5 of those cells, they're bad. And so what's happening is when you're fully charged and balanced, they all look pretty similar. There's always going to be small differences, but they're pretty similar. And what happens is as you apply a larger load to the battery, the cells that are bad expose that they're bad. They don't actually have the capacity they're reporting. And what happens when you have that situation is you get what's called an undervolt. So the cells, let's say the cells are at 4 volts. Well, this cell's only at 3.5 volts. And that delta is a problem, because if you deplete until this battery is dead, you're leaving all that capacity in these batteries unused. And if you deplete until this battery is dead, you've now undervolted this battery to a point where you've damaged it. Because if the voltage goes below a certain threshold, you actually break the battery. It damages the battery physically. So the BMS, the battery management system, is doing its job correctly. It's cutting off those cells. It's saying, I'm no longer going to use those cells. Well, the problem is when you take those cells out of the math and now recalculate the entire pack voltage, it appears to be substantially lower. And so your range goes zip. And if you push too hard, the entire pack voltage gets to an unsafe level where it thinks it's unsafe. Because remember, it's thinking, okay, total pack voltage divided by 92. And if that number goes below a certain threshold, the safety system kicks in and turns off the battery pack so it doesn't blow up and burn you alive. Because lithium-ion batteries are dangerous when they're mistreated. They're very safe when they're not mistreated. But if you have a poor BMS that doesn't properly safety the cells, they can catch fire, burst into flames, and kill you. So the BMS then cuts off the battery, disables the battery completely. And I had this happen at 70 miles an hour on the highway with a full charge. Usually this only happens when the charge gets low. It happened to me at full charge. I just finished charging and got on the highway. And I hit the gas to accelerate to 70 miles an hour. And I got to about like 68, 69 miles an hour. And all of a sudden the car goes into turtle mode. And it says EV system error. And the lights come on and the battery turns off. My throttle's doing nothing. So here I am in a car slowing down with no motor control. And trucks passing me at 75 miles an hour. Because the speed limit's 75 miles an hour here. Let me tell you, that was a pucker factor as I tried to get off the road. Now, in that situation, the battery didn't completely disconnect. It went into what's called turtle, where it limits power to 28 miles an hour. So once regeneration brought the cell pack voltage up a little bit, the battery turned back on. And I was able to accelerate again, more gently this time. If I push that too hard, it actually disconnects. And I get stranded, and I have to call a tow truck. And the only way to bring the car back is to plug it in. Then it resets. So I'm actually looking to that big battery pack that I got for review. I'm actually looking to see if I can put that resistor trick on there to use that to charge the car. Because I only have to charge for a couple of minutes for it to reset. Oh, I'm well below 125% of the federal poverty guidelines. I make less than $600 a month. I'm about to default on several credit cards, and I don't think there's anything I can do about it. In April, I'm going to default on a couple bills, and there's nothing I can do about it. I'm just not making enough money. Yeah, but what kind of help are you going to get for that? You're going up against Nissan America, who has some very expensive lawyers. No, I don't see a phone number. Did they delete the phone number? They deleted the phone number. What the fuck, YouTube? You know, the worst thing is when they shadow delete. They should replace it with something. What I want to find out is New Mexico legal aid. Okay, I will look that up. Search Google. There it is, 505-243-7871. So I suspect if I took him to small claims court, I'd probably win. I could probably convince a judge pretty easily there is definitely something wrong with this battery. I mean, especially because it's a road hazard. If it just cost me some range, it'd be a pretty difficult fight. But the fact that the problem makes the car dangerous And I reported this problem while the car was under full bumper to bumper warranty in 2019, because I had another Leaf before this. I had a 2012 Leaf. So I kind of, no, it didn't die, but I only go like 40 miles. And that's only on level ground. 40 miles on level ground. That's about my limit, 40 miles. Now maybe even more like 35, although that should go up once it gets warmer. The cold makes it worse. See, like, for example, Pennsylvania doesn't actually have a small claims court. They have something they call small claims court. Um, yeah, well, not the dealership, Nissan USA, because the dealership doesn't actually control it. Nissan USA does. I will definitely look. I'm definitely going to give them a call. Well, if I stay around here, it's no problem, but it's the big climb back from Albuquerque that's a problem. Even with a full charge, that climb's a problem because it could cause the BMS to default. And if it fully defaults, I'm stuck on the side of the road. um. Oh yeah. I have my minivan. I have the Kia Soul, and I have the pickup truck and the bus. So when I go to Albuquerque, I use the Kia. Um, More and more, I think I should have sold the car before it got bad, but when it was worth $15,000 because of the crazy used car price thing. But I have two problems with that. Even though it would have benefited me, I have two problems with that. One, if I sell that electric car, I'm never getting another one because I don't make enough money to ever buy another one. Number two, it's fraud. It's deception. I'd be selling the car as good knowing it has a bad battery. And even if I can never be caught, that's wrong. That's lying. That's cheating. That's stealing. It's fraud. And I have a problem with that. Even if it benefits me, I got a problem with that. Maybe it's stupid. Maybe it's silly. Maybe it's idiotic. I don't care. I have a problem with that. And I have to sleep at night. And that would make it hard for me to sleep at night knowing that I fucked somebody over who now bought that car and they got screwed with a bad battery. So, can't do that. But now I should have sold the pickup truck. That I should have sold. Because it's a nice pickup truck and it would have been worth a decent amount. But again, if I sell the pickup truck, I'm probably never getting another one and probably never getting the one as nice. Well, the car does have a decent warranty. They just won't honor it. Now, why Pennsylvania doesn't have small claims court? Not really. Like if I were to sue John or Ben, Pennsylvania has small claims court. But if I were to sue Nissan, Pennsylvania doesn't have small claims court. Because Nissan can simply ignore the judgment for the small claims court and then appeal it to regular district court. And now they're allowed to bring their lawyers. And now I have to have a lawyer. So in reality, Pennsylvania doesn't actually have small claims court when it's against the corporation, because the corporation, if they want to be assholes, can always just ignore the judgment and then appeal it to district court. And now you're in regular court, which defeats the entire point. Then Nissan says it's about $8,000. Now the good news is, if I get them to replace the battery, I'm going to be able to go even further. Because my car came with a 30 kilowatt hour battery. They don't make it anymore. They only have the 40 kilowatt hour battery, which means they would put a 40 kilowatt battery in my car. I'd be able to go 150 miles, which would be mind-blowing. I could go any part of Albuquerque, even in the wintertime. That would be amazing. Santa Fe and back, no problem. Oh my God, that'd be awesome to have a 40 kilowatt battery. But I would even be okay with my 30 kilowatt battery working properly, because I was going 100 to 110 miles, which is enough for 99% of what I need. So if we actually have a small claims court, maybe I could go to small claims court, and that would scare them enough, because if small claims court was binding and I won, then they would have to pay me. But yeah, I'm gonna call New Mexico Legal Aid. I definitely qualify financially, so maybe they'll be able to help me. Yes, they could, but the problem is now they can bring a lawyer. And so if the other person I'm suing is wealthier than me, it's the same as a corporation. They win by default because they have more money than I do. The whole point of small claims court was to remove the wealth disparity that prevents people from accessing the court system. That's the whole point of small claims court. Not only do you not need a lawyer, you're not permitted to bring a lawyer. You're not allowed to have a lawyer. So Nissan would have to send a representative, and they would not be allowed to be a lawyer. They would have to send a representative of the company, and we would both talk to the judge, and then the judge would decide using fair doctrine and reasonableness. Yeah, we went on to talking about taxes and KFC and weight of chicken and Walmart cans of chicken, and we just went off the rails a little bit. The actual stream ended like an hour and a half ago. We're just chatting at this point, but I should try to figure out a way to set up a voice communication, because when we only have like 10 or 11 people here, it might be practical for you guys to actually be able to talk, voice, for people who have that equipment. That'd be pretty nice to have, to do every now and then. Well, hopefully they can help. I mean, I've got enough data to show that the car is dangerous, and I can reproduce it. I can make the car do it. All I gotta do is go out on the road and hit the gas. um, I don't have the time management to manage a Discord channel right now, but yes, I have thought about it. People have proposed it. Oh, yeah, it's different from state to state. So in Pennsylvania, for example, no lawyers allowed, but they can appeal it to regular court, which means there really is no small claims court. But in some states, no lawyers allowed, and small claims is binding. They can't appeal it to a regular court. Yeah, I know. I gotta do that one day. I gotta set that up. Well, that's the nice thing about Tinkercad, is that even if you're CAD dumb, it's very it's intuitive. Even when you have to do complex things, it's intuitive how to do it. It's complicated, it's annoying, but it's intuitive, because you're mashing. It's like a kid with blocks. You're just matching blocks together. Yeah, but StreamYard's not free. Um, there's a few things that I wish Tinkercad could do. Yeah, it's probably why they allow attorneys. They're basically getting rid of small claims court. Texas is very anti-consumer. The Texas government is a very anti-citizen state. They do not like their own people. They only like their wealthy people. And so it makes sense for them to increase it to 20K and then allow lawyers. That basically says poor people go fuck yourself. That's basically what that says. It's kind of sad, because Texas is a pretty awesome place. It's just got a shitty government. Like most places. Nice place, shitty government. China's drop dead gorgeous, shitty government. um, there is no learn on Tinkercad. Tinkercad is a visual object oriented program, so there is no learn. You watch a couple tutorials, in 30 minutes you'll be building something with Tinkercad. You don't even need to watch a tutorial. Just if you learn a couple of the particular key commands, you'll be playing with Tinkercad in 30 minutes. Yes, but by allowing 20K, that now justifies attorneys, and that pushes poor people out of the court system. Because now, no, poor against poor, sure. But poor against rich, rich brings an attorney, you lose. Unless you have a slam dunk case, do you really think you, pro se, are going to win against an attorney? Not unless you're also an attorney. You're just not going to win. So you can play around with Tinkercad, and that will not inhibit anything. That will not inhibit. Like I said, it's different from state to state. Some states don't allow attorneys. But starting with Tinkercad will not hurt you. It will not inhibit your ability to learn other CAD programs, because it's not the same thing. Tinkercad is object oriented. It's like playing with Legos. that you can modify. So there's no harm to you digging into Tinkercad and playing around with it. Yes, but you're gambling. That's the problem. Depends on case and judge. You're gambling. There's no assurity of fairness and equity. And small claims should be strictly no attorneys. It should be layman's, and it should be available to everybody. And this right now, the average Joe has no ability to go after corporations. We have very limited capacity to go after corporations. That's where class action lawsuits come from, to allow citizens to go after corporations, but then only the lawyers win. you know? Until the damages to the corporation are triple what they saved, nothing will change. It's a cost of doing business. A lot of people argue that it's bullshit. Look how the government went after Chevrolet for the Pinto, and look at how many people have died in fires in the Tesla. I was like, first of all, they did not go after Chevy because people were dying from being rear-ended with gas tanks that were exploding in Pintos. Because what, like 30 people died in the Pintos? Like hardly anybody died. That's not why the government went after Chevy. It had nothing to do with the fires. What it had to do with was their reasoning for not starting a recall. The reason they chose not to recall is why the government went after Chevy. The Chevy lawyers, the bean counters, the executives, did the math. And they realized, or Ford, not Chevy, Ford. I was thinking Geo Metro, Pinto's small car, so I was thinking Chevrolet, which is actually made by Suzuki and rebranded by Chevrolet, but you get my point, Ford. The reason they went after Ford was because Ford intentionally made the choice not to recall the cars because paying off the few families that managed to successfully win in court as a result of a known defect in the car was cheaper than initiating a recall. They decided we're going to let these people die because paying off their loved ones because they're dead, paying off their loved ones would cost us less money than fixing the problem. Because remember, this wasn't a case of gasoline is flammable, and when you burn in gasoline, you die. This was a known defect, an actual problem with the car that they could remedy very easily. And when they did the math, they realized, but you know something? If we just let the people die, it's cheaper. So we're going to let the people die. That is why they sued Ford. That's why they went after Ford. It had nothing to do with the fires. It had to do with them choosing to allow people to die because it's cheaper. That's why they went after Ford. Tesla's not doing that. There is no defect in a Tesla car that they could easily fix with a recall that they're choosing not to because it's cheaper to let people die. That's not the case. It's not the same thing. All right? Batteries contain a fuck ton of energy. And when that energy has no place to go but short, it makes fire. Okay? You got a lot of power. Just like if you spark gasoline vapor, it turns into fire. Okay? So people don't understand that different. Oh, interesting. I didn't know that. But the core point here is the defect is not why they were sued. The deaths are not why they were sued. Their choice to decide it's cheaper to let people die is why they were sued. That is the government doing its job. That's what the government is supposed to do. They're supposed to be the people's big stick. When a company does something bad, the government is our big stick. That's what they're supposed to be. That's not what they are anymore. But that's what they're supposed to be. Theoretically, on paper, that's what they're supposed to be. Provide for the common good. It's right in the Constitution. That's not risk management. That's you. I'm a fucking asshole. Go fuck yourself and die. That's what that is. Putting a 2-stage fuel pump in. That's risk management. Oh my God, it's crazy. That's why this thing with the chicken should be illegal. It doesn't matter if they put in water on it. They know people are going to think there's 12 and a half ounces of chicken. They know nobody's going to measure it in general. And they know people are going to judge the value of the price based on their assumption that there's 12 and a half ounces of chicken. If you know that and you do it anyway, that's fraud. It's like, well, wait a minute. I told somebody a story about how I walked out of a bank with a pen. It was a pretty nice pen too. Not a crazy expensive pen, probably a $50 pen. So it was a nice pen, but not a crazy pen, 40, $50. And I accidentally walked out of the bank with it. I turned around and drove back to the bank and returned the pen. People say, why'd you drive all the way back to return a pen? I was like, because it's stealing. And they're like, it's an accident. It's not theft. I was like, if I took the pen and never became aware of the fact that I took the pen, then you're right. It's just an accident. No theft has occurred. Because theft is knowingly depriving somebody of their property. Okay? That's an accident. But once I became aware of the fact that I had their pen, if I now choose to keep it, that's theft. Because, well, when the police came to my store because I bought a stolen laptop, and the one officer says, well, we could charge you with possession of stolen property. I was like, no, you can't. And he looked at me like, what? And I was like, you can't charge me with possession of stolen property. I have to know it's stolen property. He's like, well, we're telling you it's stolen property. And I was like, and I gave it to you, didn't I? And he's like, yeah. And I was like, so it's not possession of stolen property. You'd have to know it was stolen. That's why you came and asked for it back. Now, if I chose not to give it to you, and now I know it's stolen, now it's possession of stolen property. And his buddy looked at him and goes, he's right. Now, of course, there's mitigating circumstances. Like if I bought the thing for $100, well, then yeah, any reasonable person would understand it's stolen. But I actually paid a reasonable price for it, and I even searched the serial number to make sure it wasn't stolen. But of course, the guy who it got stolen from, he hadn't posted yet that his laptop was stolen. But but if you take something, now there's of course mitigating circumstances. If I walk out of the store with somebody's Bic pen and I'm 20 miles away, I'm not going to go return their Bic pen. It's worth 5 cents. Call it petty theft. But the cost to me to return it exceeds the value of the item. And nobody would expect that to be returned. But a nice $40, $50 pen, yeah, I'm going to go return that. They paid good money for that pen. Sure, it cost me a 25 cents in gas. So what? But that was before I had the electric car. Oh yeah, for real. They're good. Well, it looks like the mayor's finally starting to react, but man, are they getting the shaft? Jesus. I love when people say, "Well, you're not considering all the slave labor to collect the lithium and cobalt for your electric car." And I was like, oh yeah, let's talk about all the slave labor to dig the oil for your oil fields. Oh, did you forget about that? Every time somebody compares the carbon footprint of an electric car and the carbon footprint of a gas car, and say it doesn't make sense. The gas car is cleaner because it takes more carbon to make an electric car. Well, that's because the electric car includes the fuel. You're including the battery. If you want to make it an apples to apples comparison, you have to add the 11,000 gallons of gasoline your car's going to burn in that time. Now suddenly the carbon footprint ain't the same anymore, is it, buddy? You just forget about the 11,000 gallons of gasoline. How convenient. I have a Nissan Leaf and a Kia Soul, my Soul Reaper. I had a guy ban me from his TikTok stream yesterday. He's being a dick, and he's trying to say how nobody needs an AR-15. I was like, you do realize that one of the worst mass shootings in U.S. history was done with a single-shot bolt-action 22 caliber rifle. And he's like, well, the worst shooting was Las Vegas. Nice try there. And that was with an AR-15. And I was like, hey, buddy, I said one of the worst, not the worst. He's like, well, excuse me if I didn't read your comment right. I was like, it's the first 4 fucking words. One of the worst. It's like you ignored the first 2 words. How do you read a sentence and jump to word 3 and start there? And so he muted me and banned me. People have a single track mind. They don't care about facts. They don't care about reality. They want an end goal, and they're gonna twist reality around itself to get to that end goal. People don't realize that the U.S. does not have a gun problem. We have a poverty problem, not a gun problem. I don't see people in Finland shooting up their schools. I don't see people in Canada or Australia shooting up their schools. I don't see people in any European nation that allows their citizens to have guns. I don't see them shooting up their schools. It's a uniquely American thing. Now, people say, well, you have a lot of guns. I was like, really? So a lot of guns equals school shootings, but not a lot of guns doesn't equal school shootings? That doesn't make sense. It might equal less school shootings. So if you have half the people and half the guns, maybe you'll have half the school shootings. But if the guns were causing the school shooting problem, you'd also have school shootings because you do have guns. You can still get guns in Australia, but it's very restrictive. Rifles, no handguns. The point is, there are countries where citizens can lawfully have guns and they're not murdering their children in schools. Which means the guns aren't the problem. But what is different about those countries than the U.S.? What is different? I can tell you what's different. Wages, healthcare, mental health care, poverty, corruption, a social safety net. Those things exist in those countries and don't exist here. There's your problem. We don't have a gun problem. We have a healthcare and poverty problem. And guns are just the outlet. Matter of fact, even with our problems the way they are, even with those problems, we don't have an appreciable gun problem. Our death per capita to gun homicide is on par with Finland. But 65,000 gun deaths a year. Yeah, and 42,000 of them are suicides. 5% of them are justified, police or citizens in self-defense. And of the 30% that remains, 90% of that is gang violence. So if you put aside the suicides and the gang violence into its own category, because how much gangs do they have in Finland? None. Okay? And then you compare the remaining gun homicides, the per capita rate is on par with Finland. We don't have a gun problem. We have a poverty and healthcare problem. We have social problems, not gun problems. You think people who are committing suicide are going to suddenly not be suicidal anymore because I don't have access to a gun? The 65% of gun deaths that are suicides, 65% of gun deaths are suicides. You think those people are going to magically, unicorns and glitter, stop being suicidal? They'll find some other way to off themselves. The problem is not them having a gun. The problem is them wanting to off themselves. You gotta fix that. You gotta make them not want to kill themselves. uh, but the problem is people, these people are not anti-violence. They don't care about violence. It's like, people who are anti-abortion don't care about children. Because if they cared about children, they'd fix the welfare and poverty problem so we could take care of children. No, they care about their religious agenda, their political motivations. And all this stuff about, right to life and caring about life is just a cover for the political agenda, the religious agenda, the misogyny. Why do you think it's so common for women to have contraceptives, but not common for men to have contraceptives? Do you know how hard it was just to make condoms acceptable? Well, how we are men, we are perfect. How dare you suggest we do something? No, let the women do something. Even though the men are the problem. Women can have one baby every 9 months. Men can impregnate 30 women a night. You want to stop the baby problem, you deal with the men, not the women. But because misogyny, women inferior, men superior, we do it backwards. And women have to take birth control, which has a 50% chance of causing blood clots. I never knew. The reason my sister is sitting in her room with an oxygen machine is because birth control pills, which helped her control her cramps, gave her a blood clot that almost killed her. And this is normal. I mean, they're women. Who cares? It's their problem. Wow. Well, obviously, she stopped using them now because otherwise she'd be dead. Yeah, I never knew. Birth control pills, 50% chance of blood clots. 50%! If you told me there's a 50% chance of surgery failing, there's not a fucking chance in hell I'm taking that surgery. Not unless the chance of me dying is 100%. A lot of doctors won't do surgery if there's a 5% chance of death. The risk is too high. But 50% for birth control, no problem. You can go get it prescribed from your doctor. See you later, DeWitt. It's mind-blowing. It's our society is so fucked up. Oh my god, our society is so fucked up. How has it not collapsed already? How has it not collapsed under its own weight already? You want to watch a good movie? It's good space history, but it's also going to make you angry. It's going to make you very angry. There's a movie called Hidden Figures, and it talks about the computers for the space program. Now, you're thinking the wrong word unless you know history. Computers are people. At the time, we didn't have computers, okay? Everything was done by hand. And computers were just starting to become a thing. The people who did the calculations, they were called computers. Right? What's your job title? I'm a computer. Literally, we called them computers. And there was a lot of women, black people, minorities, stuff like that, very good at math. Natural talent for it. And so they did all the calculations for trajectory and re-entry and weight, mass, and thrust and all that stuff. They are the ones who said whether that rocket would work or not, and when they would, what angle they had to hit the atmosphere, when they had to fire the retro thrusters for how long. This is all done on paper. This is all done, by people on paper with slide rules and pencil, and it is crazy. It's amazing. The shit we did before computers is just mind blowing. And there was this one scene in the movie that was just, it was so good. If you, I bet you, if you do a search for Hidden Figures bathroom on YouTube, I bet you it'll pop right up. Um, but the way we treated these people back then, it makes you wonder how many Albert Einsteins have we lost due to our racism and misogyny? How many geniuses that could have changed the very fabric of our world got tossed in the gutter because they were black or female? It's you're gonna love the movie because it's an amazing movie, and it's gonna make you rage inside when it hits you. Just the absolute stupidity of it. No, you can't say the same thing about abortions. That requires time travel. That's like the trolley problem. The trolley problem is you're on a railroad track and you're about to, hit some people on the track who can't get out of the way in time, and you're going to kill them. Okay? Or you can flip the switch and change tracks, but now you're going to kill those people. And usually it's a different group of people. So we'll say, well, these are old people and these are children, or these are criminal, or these are nuns, to see how we would weigh people's lives against each other. And the problem is because these people existed, right? If you want to take the ridiculous abortion issue to its final conclusion, then if a woman asks me to have sex and I say no, then I'm killing a baby that could have been. If I wear a condom, I'm killing a baby that could have been. It's no different than an abortion. Because, first of all, the vast majority of babies aborted are non-viable, meaning there's something wrong with them, they're a threat to the mother, etc. And you might have, neither does the embryo inside of you. You might have one shred of moral fiber to stand on if you supported welfare services to make sure no kid ever suffered. Because otherwise you're a fucking hypocrite. But of course, once the baby's born, not your problem anymore, right? So it's all politics and religion and not actually giving a fuck about the baby. Because once it's born, you make it quite clear you don't give a fuck about the baby. But the way I see it, and the way science sees it, is that babies are parasites. Until that baby is born, it's a parasite. It's literally parasitic. It is taking the life energy of the mother. If that baby becomes a danger to the mother, it should be between her and her doctor as to whether or not she should keep it or get rid of it. Now, would I have enjoyed it if I were aborted? Well, I wouldn't know. I wouldn't have been born. Okay? But that's no different than dad wearing a condom and I was never born. Right? You take it back to its ultimate beginning, and any not having of sex is an abortion of a sort. This has nothing to do with right to life and crap like that. It's all about control. You could clearly see it in the way they're wording these laws and the way they're trying to word these laws. I'm talking about people who exist, who are intelligent, who are innovative, and they're being suppressed with misogyny and racism. I mean, these people are calculating orbital trajectories on paper. Can you even calculate an orbital trajectory with a calculator? I can't. And they're doing it on paper. They need to be showing your feet more often. You got to change your name to Footman. Or show me your feet. That should be your username. So even though yes, it could be the next thing, the next genius that you abort, it doesn't matter. You don't have a right to force someone to parasite from, to be parasitic from. If there's a leech on me, You can't say, well, that leech could evolve into the next species to go into space. It doesn't matter. It's a leech. It's my body. My body, my choice. All right? If I decide I don't want that leech on me, the leech is gone. And if a woman decides she does not want that baby anymore, she should have the right to get rid of that parasite. Do I like it? No. Would I like to see the baby born and given to a family who would care for it? Yes. But it's not my baby. It's not my body feeding it. It's not my body the parasite is taking from. It should not be my say. Would I like to see abortions outside of necessity eliminated? Yes. Should I have a say in the matter? No. Because I'm not the one who has to give birth to it. When we have to, there have actually been cases of a woman going into the trash can, grabbing the condom with the cum in it, inseminating herself, and then later claiming child support. Yes, that has happened. And she won. There have been rape victims who have had to pay child support for the result of the rape. Yes, men get raped a whole lot more often than you might think. It's absolutely insane. It's now I think some of those laws may have been changed over time, but I bet you a lot of them haven't been. But it's this country's fucked up, and it's a lot of it's based on religion. Religion is evil. Religion is very, very evil. Not faith. I'm okay with faith. I don't believe in faith, but I'm okay with faith. So I guess for me, think of religion as incorporated faith, commercialized faith. And if you corporatize it, I consider it evil. If it's just something that is your faith, I got no problem with that. You want to believe in a fictional deity in the sky? Fine. There's nothing wrong with that. You might be right. um, but when you start to impose that on other people, and that's what religion does, it imposes it on other people. For example, here's one that Christians don't like when I tell them this. Do you want to be a perfect Christian? If you want to be a perfect Christian, if you want to make your stated goal your actual goal, you want to bring everybody to Jesus and have everybody go to heaven. If that is your intended goal, is to bring Jesus to everyone's lives and everybody goes to heaven, then a good, proper Christian, the moment they decided they believed in God, would take a vow of silence about their religion and never mention God to another living being ever again. Because there is no way in hell an omnibenevolent God is going to take a person who does not believe in God because they've never heard of God and they lived a good, sound, ethical, moral, proper life, and they simply don't believe in God because they never heard of God. That person would make it into heaven. But the moment you know about God and reject him, you're going to hell. So by proselytizing Christianity, you're being anti-Christian. Because you're taking the chance that everybody you tell about God who doesn't believe in God and chooses not to accept God is now going to hell. You are sending that person to hell. Because if that person never heard you mention God and they otherwise lived a good Christian style life, they would go to heaven. And you now took that from them by mentioning God and them rejecting him. So a good, proper Christian would take a vow of silence the moment they became a Christian and never mention Christianity to anybody ever again. Because that would maximize the number of people who Jesus would come to and they would go to heaven. Assuming they lived a good life. Because it doesn't matter if you believe in God, if you live a bad life, you're going to hell. Okay, so a good, proper Christian would never mention Christianity. That's why faith good, religion evil. Because the purpose of religion is indoctrination. The purpose of religion is to compel people to believe what you believe and to believe the way you believe. That's not the purpose of faith. That's the purpose of religion. That's the purpose of your incorporated church. That's the purpose of your 501c business commercialized church, religion. So I'm not anti-faith, I'm anti-religion. Buddhist, fine. Hindu, fine. Christian, fine. Catholic, fine. I don't care. You whatever you have faith in, I support you, I believe in you, and I hope for the best for you. Religion, fuck religion. Should be banned. Because every single one of them, without exception, gets twisted and distorted to control people, manipulate people. That's the reason the United States has a separation of church and state built into the Constitution. The First Amendment is not guaranteeing your right to religion. It's protecting you from religion. It's because religion is whatever the superior religion of the time is. So whatever the currently in vogue and largest population count religion is, that's what they're protecting you from. They're protecting you from being forced to believe what we believe or else. Like the Crusades and all that crap. So that's when religion gets out of control. Because almost all religions, almost all faiths are started with good intentions, are started by good people trying to do something good. I mean, why does Islam say don't eat pork? Because at a time when we didn't understand microbiology and parasites and disease and bacteria, we didn't know why, but we knew the people who ate beef weren't dying, and the people who were eating pork were dying. And as the shaman for my village, as the religious leader of my village, as the faith leader of my village, it's my job to protect my people. I don't know why these people are dying, but I am damn certain it's the pork causing it. But how do I tell a bunch of savages to stop eating something that's available, delicious, and good for them otherwise? How do you get them to do that? Well, you say, God said it's bad and you'll be damned to hell if you eat it. That's how you get them to stop eating it. And guess what? Your people live. Your people get to live. So it was good intentions at a time where science couldn't help you because you didn't have enough knowledge. You just didn't understand. Now we understand. We know why pork is dangerous. And we know how to make it not dangerous. And so pork is safe to eat now. The religious prohibition is just a carryover from that. It should be abolished. Your own religious leaders should say, God has provided us a way to make pork safe, therefore we no longer need a prohibition on pork. Because that's the truth. You now know how to make pork safe. And that's the way most religions start, I think. I have to believe that it's good people trying to help their people. And religion was a way to do that. Faith was a way to do that for a society that was savages and backwards and barely understood agriculture and sure as hell didn't understand. I mean, even as short as 100 years ago, we didn't understand basic medicine and cleanliness. Washing your hands was a good thing. It was barely 100 years ago that we figured that out. So it's understandable to a point. Just it gets out of control, and then you got to start eating people. That's my solution. Mean people taste good. Remember that. Mean people taste good. Oh my God, what a messed up world. What are you going to do? Alrighty, it's 4 o'clock. I'm getting hungry. I haven't had breakfast or anything. I'm going to go get my turkey, and I'm going to put that thing into a rotisserie. Or maybe I'll make sandwiches again. I don't know. I got some rotisserie chicken deli meat. Normally I couldn't afford that. It's like $6 a pound, but I got a $2 coupon, so it was like $4 a pound. I was like, okay, I'll buy it. It was good. Some shredded mixed Fiesta cheese with some Duke's mayo, which doesn't really taste much different than regular mayo. I mean, it's good, but it doesn't really taste any different than the other mayonnaise I have. I heard a lot of people talking up Dukes, and I had coupon for it, so I grabbed a couple, but it's no big deal. My palate must not be good enough to taste the difference. So last night I toasted up some sourdough bread because Walmart has sourdough bread for $2 a loaf with cheese, mayo, and horseradish sauce and chicken. It was good. Yeah, it was yummy. All right, I will see you guys later. Oh, I should have another video out Sunday. I got to start releasing regular videos because they make the ad revenue. Live streams don't make the ad revenue. So I've got to start ramping up the regular videos. I got to get back into doing that. And hopefully as the weather warms, hopefully the next couple weeks we will fly version 4 of this rocket. Make sure it works so people can fly it. And I want to get the glider going. I might work on that tonight. I'd really, because it wouldn't be that hard, especially the wings. The wings is the big test because they're the big part. It would be pretty easy to modify this to print on a 0.4. All I'd have to do is grab my cuts and shift them 0.2 millimeters closer. So I ended up, no, wait, how far? 8, yeah, 0.4. I got to shift them 0.4 so the gap is 0.8 instead of 1.2 for the 0.6 millimeter nozzle. And then print one of these on the 0.4 millimeter nozzle. It'll be half the weight, but to see, will it be strong enough? I don't know. Until I print it, I won't know. I mean, this seems pretty strong with 0.6. I might need a couple more reinforcement ribs, like maybe put a little one here and a little one here and a little one here, just to add little ribs to help stiffen it up a little bit, because it'll only add a couple grams. But that'll make a much, much lighter wing. Another thing I might need to do, you can start to see layer deviations at the top because it's such a tall, skinny print, it starts to wobble a little bit. So I might need to add some reinforcement triangles at the bottom here just to spread the base a little bit that you'd have to snip off. A better solution would be to flare out the end of this so that the actual wing root was thicker, and that would provide the more solid base to attach to, but that would be difficult to do in Tinkercad. So that's beyond my abilities. So I might just have to add a couple of triangles to give it a bigger base on the bed so it holds steady, and then I'll just have to snip them off when I go to fly it. But yeah, I want to see if I can make this lighter. See how light I can make it while still being strong enough to sustain, 150-mile-an-hour liftoff. All right, I will see you guys later. You guys have a great night, and I will see you next week.